Okay.
Okay.
Yeah.
I mean, the book
There's
I just ordered from Oxfam, I think the book was £7, but the postage was half of that again. It's still a bargain.
No, no, seriously, I looked at it, and thought that's ridiculous. I'm not paying $6. And then I thought, wait a minute, it's only $6. Come on. Okay.
Oh,
Is that me? That's me.
I knew it weren't me because I'd made sure I was bloody muted.
I'm sure I was muted too, but
it's okay. It's Terry, he who's in charge of the stream.
Yeah. Well, I had Lindsay opened and he was muted, and then I forgot to leave the other tab open for us, so make sure we weren't muted. We were muted. Yeah. We weren't.
Because usually when it says it's waiting for, you can't see whether it's muted or not. And I usually open up another tab with YouTube on, go to play a video and see if it's muted or not.
And we're just waiting for Paul to finish his breakfast.
The trouble is, when you click the link, you always end up with whatever the audio is set at on the video you're currently watching.
Yes.
So I'll sometimes click the link, think, oh, okay. Close the window, open another YouTube video, mute it, and then click the link.
Yep.
Okay, so I don't know if anyone's guessed yet, but I've left the live chat at Paul's question. L something S was an American-Hungarian physicist who was one of the first to recognise the significance of the nuclear fusion reaction.
Fission.
I thought it said fusion. Oh, fission, sorry.
No. Oh, it's an important distinction between those two.
Okay.
It is, yeah.
Okay. He built the first nuclear reactor with Enrico Fermi. I have heard of that name. So it's not Leo Savlaki. It's not Leo Sawyer.
It's not Leo Savlaki, no.
And Carl Edwards has taken a punt at Leo says something.
Yeah, no echo cakes because we sorted that out last night. Dora said hot mic.
Yeah, there was.
Okay.
Yes. That was Terry. Yeah, because Pip said to me last night, did I see that Terry live streamed yesterday? I said, yes, it was just to iron out the the many bugs in the audio setup.
Okay, we've got a Stevie B with Leo Shizard, Lizard.
He's got the name correct, but I want to know how Terry's pronouncing it. Yeah.
Sillard.
Silard, yeah.
Oh, so pretty much a silent S.
Yeah.
Well, I suppose, yeah. What was the American? Hungarian. Yeah, the Hungarian names can get a bit.
I was going to say Hungarian or Polish origin for that name.
An excess of consonants, yes.
Especially S and Z.
God, I did read a book. A bloke was covering. I think it was towards the end of the Second World War in a part of Poland or something. I can't remember. But he was explaining how the Polish words are pronounced, and you just look. I can't remember that. It's all over the place. It's nearly as bad as Welsh. Doesn't bear the letters don't bear any resemblance to how you bloody pronounce it.
Yeah, and an excess of consonants.
Yes, an excess of consonants. Yeah. Can I have a vowel, please, Carol? No, come on, keep going. Keep going. We need more.
Yeah, I have a consonant, Carol, and another one, and one more,
and another one. Yeah, Polish words aren't allowed here, mate. Oh, bugger! I'll have three vowels, please.
I had a student once, and the surname was HRYCSYZYN.
Popularly known to everybody as mate.
As alphabet. Herocession was how you pronounced it.
Wow.
Yeah.
Yes, Dora. Is the only Welsh you really need to know.
Flossie. Oh, that's lovely, isn't it?
Well, I'll take George Natchik's name spelled and to have a crack at it.
Yeah.
Yeah.
I know.
I have one of the carers that come. I cannot say her first name. I can't pronounce it at all. I believe it's Farsi.
No. Unfortunately, the rather nice Slovakian engineer that I'm sort of taking over for, because she's off on maternity leave soon, Ivana. That's easy to pronounce. So's her surname. It's actually, yeah, it's yeah. I think it's Rusnikova. You know, there's no excess letters in there everywhere. It basically reads as you look at it. You know, think, oh yeah, that's okay. Yeah, I think she's from Slovakia. Needless to say, her English is better than my Slovakian.
Yeah. all of the young ladies that weren't born in the UK that come visit, their English in general is also really very good.
Yes, we've got several. Some of the people are ladies from the Eastern Bloc, as was, and yeah, their English is very, very good. And it does sometimes it makes me a little bit ashamed that over here in the UK we tend to be very, very lazy when it comes to learning other languages.
Yeah, I know. I do know.
But the problem is, which language you learn when everybody else has already learned English for you. Thank you very much.
Yeah, especially because you're so close to countries that have other languages, farmers.
Yeah.
But here in Australia, like they're sort of far away.
Well, when I was at school, in the last few years of I suppose what you call high school, we never called it that. I had two choices. It was French or German, and I wanted to do German. But if I wanted to do German, I had to do French as well. I just did not want to speak French. I've got no interest in speaking French whatsoever. So I just did French for the one obligatory year, and then we got to our option stage. I dropped it like a hot potato. And I really wish now that I hadn't been quite so, oh, I'm not doing that. I really wish I'd done French and German, because at least I'll be able to speak German now. Given my interests.
Yeah.
One of the few regrets I have in life. I wish I'd stuck at it, but that was the only choice we had. It was French and German, and that was it. That's what, mid-80s, and now of course we're dealing with God knows how many countries.
And it's a shame it was French and German and not French or German.
Yeah, if it'd been French or German, I'd said, right, sign me up to do German for the next 3 years. That's what I wanted to do. I didn't want to speak French. Still don't. And of course, the French tend to be quite the same. They don't like speaking English. Now you go to Germany, as we did. We had a weekend break in Berlin, and everybody speaks English. And when they realise that you're English, you're from Britain, they're quite happy. And at the restaurant we stayed at one night, the owner came over and he said, "Look, do you mind? My lad here is training to be a waiter, and he's working on his English. Can he be your waiter for the evening? And you can help him with his English?" We said, "Yeah, of course." Because he was delighted. Oh, look, it's an English family, right? They can help out. They can help teach you how to speak English. I thought, yeah.
Yeah. Just be careful which combinations of words you're teaching.
Yeah, that's all right.
Right.
Most people know how to swear in English. That's one of the first things they learn when they come over here.
Yeah, I have to be careful. I have taught some of the non-native English speakers some word combinations that they really shouldn't use in the job that they were doing.
Yeah. Oh, I like Stingray's comment.
Yeah, I was trying to figure out that one.
Ah, Joanna Wang. Do I want to what?
Yeah.
Oh, yes, please. Go on then.
Yeah, how do you reply?
Probably the same way that Stingray did. Pardon? Come again.
Dora's speaking French.
Yeah, whatever. Of course,
All
the
I
only
know,
German I know
all I know is
is
parlez-vous français, mademoiselle.
I know such handy phrases as "by the machine from Fenster House," which I think is both engines half ahead. Well, keep watching this 5-hour long film about a U-boat patrol, and you have to watch it in German with subtitles, and you know when the subtitles are lying because I know what he said, and that weren't that. I've only the BBC over here. I think they showed it because Das Boat is a approximately 5 1-hour episodes. You know, it's a made-for-TV film, and I think BBC Two showed it over here in the early 80s, and it had the right subtitles. And I've never seen it in that form ever again since. I've got the German Blu-ray version of it, and even that subtitles are wrong.
Wow.
Yeah. Some of the descriptions of what they're going to do when they get back to port and enjoy those German nurses and German telegraphists and all the rest of it, they're quite descriptive. I've never seen it in the subtitles properly since.
Dora said her French is very bad.
I know a little French. He's just over there.
Well,
I know a little German.
Yeah, his name's Fritz.
Yeah, his name's Fritz. Here he is.
So have we got anything else on the cards besides Lindsay?
I don't know. Have we?
Nothing I've prepared earlier. Been waiting for something else to pop up. Especially something similar to the one we watched the other day with the module on the space station.
Leo's face-palmingly sad video. Mr. 42 did a response to it. I noticed this morning DKG Custom has done a response to that and a couple of other things, but that's only about 4 minutes long. It's been a little quiet on that front, I have to admit. There don't seem to be too many videos coming out at the moment.
Yeah, but you never get a retraction though, or get taken down.
The only one that I'm aware of, particularly a Level Earth Observer, was they had a shot inside the ISS with I think one of these 360-degree cameras.
Mm-hmm.
And he did a quick video on it and said, "Oh, look what happened! Look, their CGI screwed up." As the astronaut sort of floats past and goes through that point.
Yeah, I know the one you're talking about.
And then and he went, "Oh, look at that! You know, CGI, all of that rubbish." And then somebody said it's a 360-degree camera, and the video disappeared.
Exactly.
And I feel he's almost done the same thing with this one. They're saying, "Oh, look, that's the capsule's up one way, and then it's up the other, and the horizon's all wrong." And somebody went, "It's 2 capsules, you know." And instead of just going, "Oops, yeah, I'll delete the video," I think because he'd got so many comments of support, because that's what he's after. He's after the interaction. He got all of these fellow idiots going, "Oh yeah, great catch, well spotted. Oh, CGI, it's impossible to be in the vacuum, blah blah blah." That he's left it up there, and then he's linked to a private video where he's trying to sort of say, "Oh well, yeah, but why didn't they have a camera showing that second unit?" Well, they did. They did. It's in your first video. They've got a camera doing the big shot, and then they've got another camera actually focusing on that particular pod, and you can watch it undock. The argument doesn't make sense. They've got cameras showing all these things. What they don't have is cameras showing every single square inch of the ISS. Because why?
Yeah.
I have heard about something what Cakes is talking about. There's supposed to be another movie out. It's called Level 2. I don't know if that's the same thing I'm thinking of.
There is. It seems there's not what.
I don't know how long it goes for though.
I don't know. I haven't actually watched Several YouTubers have commented on it already. I'm sure Simon Dan's covered it, hasn't he? Or did he?
Yeah, several people have. The trouble is, it's really long, and there's like not really any content.
No, there isn't. It's all just jibber. There's
okay. So does have to be played 4 times Lindsay speed then?
And it is just the usual idiots plus some woman nobody's ever heard of who think is a sort of a newbie to the flat Earth.
Okay, we're going to get new names for it now. Level 2, the quest for more derp. Well, it's not Flat Earth Day today, Gary.
Level 2, the Wrath of Derp.
Yeah.
But no, that can't be right because it was always the even-numbered films that were good, weren't they?
Level
2, Star Trek 4, Star Trek 6.
Level 2, the Revenge of the Sith.
Level 2, the Derp Strikes Back.
The next level response. Who's that from, Ball?
What?
I don't know, I'll have a look. No, in Ball.
That's Arctic Reflections latest.
Well, that goes for 7 minutes, so that's okay. If anyone else find anything in response that's similar or different or better, or if not, we'll leave it at that one.
Yeah, because he's had trouble putting the videos together at the moment because he's sort of out and actively serving, isn't he?
Indeed.
Okay.
Which kind of makes it tricky to do YouTube videos.
Mm-hmm. Oh, well, if that one will do, if anyone else has got no other objection, we'll use that one. If anyone knows a better one. If
Lindsay's done at least 3 videos in the last 4 or 5 days.
Yeah, I've got that out here. I've got that ready. I've got his flat Earth's flat, quantum physics theorists, and I found singularity. Okay, that sentence doesn't sound complete. I found a singularity. No, I found singularity, not...
Oh, that sounds a bit zen.
Yeah.
Yeah.
I'm sure there's a word missing somewhere.
Yeah, probably.
Well, anyone got a cup of coffee ready, or they need to go and make one?
Why? What are we getting inflicted on us?
Well, I just went and made mine, so I'm safe.
Oh, well, you're all right. Yeah.
I was going to pull my YouTube book and go make a cup of tea when you put Lindsay on.
Okay, then. We'll do that.
A cup of tea, of course, I'm not really allowed to make.
That's right.
Well, we won't tell anyone, Alan.
But you're a rebel, so hey.
You could always use cold water, Alan.
Oh, no.
Oh, a cold cup of tea. How many of them have I had when you're too busy working? You think, I've still got some tea left to go and take this swig of it.
Well, you know you can buy iced tea. And that's cold.
Yeah, that's not the same drink.
Well, the point is, when you have iced tea, you have to make it with boiling water first.
Oh, okay. Okay.
I mean, I can just about manage cold coffee because I have it black, so that's sort of vaguely drinkable. But a cold cup of tea is just a number of times I've done that because you get busy whilst you're working and you forget it's there. Oh, I've still got some tea.
Well, I know Blue's got a job that you can do. He can go and find his book.
Oh, he knows where it is.
Oh, okay.
He just doesn't want to go outside in the rain to get it. I can't understand because over here, the postman always brings the mail all the way to the front door, don't they?
Yeah, but that's usually where our letterbox is. It's in the front door.
Exactly.
Why? Because it's always raining and you don't have to go out to the letterbox then?
Yeah.
I'm assuming that Blue it still has it like it's always traditionally shown in the States, where they've got this really long ass garden in front of the house, and then right on the edge of the property, there's your mailbox.
With that lever on top that gets pulled down when there's mail.
Right.
Yeah.
That's the way it works.
That's it. I mean, you do have that over here. Places like farms where they're half a mile back from the bloody road. Yeah, their mailboxes at the front to save the postie going all the way down there. But usually, like my letterbox is in the front door. Unfortunately, because it's got a bit of a porch over the front, if he can't fit it through and I'm not here, he can just leave it propped against the front door, and it won't get wet if it rains.
But the other advantage for the posties over here is if the letterbox is out the front, he doesn't have to get off his motorbike.
Oh no, our chap goes. He has a big trolley he pushes around, and he gets to every close, gets an armful, and then just walks around.
And they've upgraded now. They've got electric trikes. So.
Oh, very green.
Yeah, the house I grew up in as a kid had a letterbox built in the front wall right next to the front door. Mail slot there. The mailman put it in this little door inside the house. Never had to even open the door. Yeah, it was great.
Yeah. Same we got.
Times have changed. Now it is not. It's not optional. You will put a mailbox out front if you want mail.
Yeah.
All right.
Yeah.
Because our mail people cannot be bothered to get out of their damn truck and do anything.
Ah, right. I see.
They even get right-hand drive, don't they, on the truck? So they're against
they do.
Curve as they're driving along.
That's really, really lazy.
No joke.
Wow.
What's Mum Bakes Cakes posting? No, I've already got Arctic Reflections.
Yeah. We got him.
I already got that one.
Microwaves were invented to reheat cold cups of tea.
Without milk, because it makes the milk go funny when you...
Yeah, exactly. You just tip it down the sink and put the kettle on again.
Yep.
Yeah, exactly. Job done. Easy peasy.
And then try to remember
how much mail do you get each week, John? You get a 44-gallon drum.
Or does he just let it fill up and then throw a match in?
I was thinking that. He fills it up every year and just goes and checks it once a year.
Because that's how they still burn the rubbish on the farm back home. They only put out that they can't burn. Certainly back in the day when we didn't have wheelie bins, everything that was burning went in the 50-gallon drum. You got to the end of the week and just threw a match in there and burnt the bloody lot.
How's Dora? Maximum distance to the letterbox is regulated in the Netherlands. If it's more than X meters to the door, there needs to be a separate letterbox within the X meters.
Meters. Wow.
Okay.
So X equals what?
X equals 10 meters maximum distance from public road.
Oh, so the house could be a half a mile away from there, but as long as it's 10 meters from the public road.
Yeah, I see it around here all the time. A lot of the farms and that they're offset from the road by quite a distance, so they generally have a separate lockable mailbox. Because usually the road or the driving lane to the farm has got a gate or there's got gate posts or something, and they stick a lockable, decent sized mailbox on the front of it, so the post you ain't got to keep driving all the way up and down these bloody roads. You can just pull up and hoik it in. You come pick it up when you can be bothered.
And unless there's a parcel to deliver, in which case,
yeah, parcels are something different, but
okay.
Or the good old recorded delivery.
Yeah.
All right.
Oh, good. It's time for tea.
Yeah, go and make your coffees and go and milk your cat and feed the cow or whatever it is.
He's
27 minutes and 13 seconds on again.
Yay! He's cleaned the board as well. Well, some of it. He's had to have another go.
No, he's still got that one over on the right.
Yeah, but that left-hand side, he's
cleaned that side off.
He cleaned that and started again. It was getting a bit of a state, bless him.
Yeah. Okay, where's Lindsay's speed?
There we are.
Yeah, we should edit that and put Lindsay speed there.
Yeah, but the rest of the world won't understand what it means.
Oh.
We know what it means.
Okay, Dutch letterbox specs for those that care, enjoy reading. Oh, I'm not going to open that up while I'm doing this, so unless you just want to open
Especially that it's probably going to be in Dutch.
Yeah,
it.
but
Yeah, that wouldn't help.
Yeah, but Google translates it to English for you. You know.
Farm mailboxes here used to be sequentially numbered, but they changed that system, and now the farm letterbox number is directly related to its distance from town. So if you're 15.8 kilometres from town, your farm letterbox number will be 1,580.
All right.
Anybody want to hazard a guess what a 4-letter P word is?
Well, I can think of several.
Okay.
But I'm guessing you're after the one that says, press play, please.
Okay.
Oh no.
Can I re-edit that word simple form? Yeah, we need to re-edit, voice over that bit.
Well, you know what you thought about that.
Oh, I can't hear Lindsay. Can't hear Lindsay. Can't hear Lindsay.
Oh no!
Oh no.
Get back and check them out.
Sorry.
Oh.
Sorry, Peanut.
This is the
I know what it was.
flathead system, right? Sliced through the guts, looking down on it. It's basically like that. That's the northern hemisphere. Look at it. Look how small it is.
Do you want me to
compared the southern
rewind it,
hemisphere.
Spook?
What I haven't drawn is the tropical gap. So we could draw that in there now.
You know, I suppose we've only just started, so it probably wouldn't do any harm to start again,
Yeah.
would it? I mean, we want them with any of these
So
absolute pearls.
basically,
Yeah.
They've got a
Here's the northern
sucker
hemisphere.
too.
Yeah.
and there's the
Yeah.
southern hemisphere.
Having
Same
said that,
size overall, aren't they? But look at this image compared to this image. They're different, aren't they? And that's our flat earth system. That's the two different sizes. That's what they call the electrical potential difference. There's this field here, there's a choke point in the centre of the earth,
Electrical potential difference.
It's-
Okay.
condensed into a strong magnetic field, a vortex in the centre here. And out here, there's a reflection. It's a parabolic image because the earth curves down in the southern field.
Jaren said it's better with the sound off.
And we get these two pictures here. This is way bigger than this. So overall, the energy field, the energy in here, it matches, is equal to all the energy around here. But because it's more widely dispersed, it's a weaker in relation to in here at any one point around the Earth. The electrical potential difference, and this is what keeps a magnetic field flowing and an electrical field flowing to find equilibrium. Is the strong force rushing to the weak force, the weak force rushing to the strong force to find an equilibrium.
So much wrong
But
with
they
it.
never find it here. So if they did, it'd be flatlined. And what happens when you get flatlined? Doesn't exist. No energy exists. You're dead. Everything in our room is frequency based. It's all to do with waves. And if that wave got flattened out to flat line, then we're all gone. It's always a continuous wave. Electricity is a wave. There's a frequency. So everything in our realm is frequency. So it's always a wave. What I was just thinking about the other day was how, like, it's a parabolic image, and how I'm telling people how those images, the star images in here, are the star images out here. Nobody believes me or can get their head around that.
Well, what are the
But it's
stars you're
100%
seeing in
fact.
there then?
What is in here is out here, but more widely dispersed. So
Not the
I came
same
across
stars though.
Ursa Major, which I'm in the southern hemisphere, so I'll see it here. On my zenith, which is direct north to south above me, Ursa Major will be back here somewhere. As
I'd give it
the
another word
constellation
that
of
starts
Virgo.
with S, T, guy.
Then I'm looking south and I
What it
see,
sounds like.
looking north-ish. This is where I was lost for a minute there. I'm looking north-ish. And I
Northish.
see Orion's
Northish.
bow.
Yeah, northish, yeah.
And I look over here and see a much
Are you
bigger
looking southish,
bow.
the opposite way?
I started thinking, well, where did I come up with this? It just all came naturally to me. I mean, a lot of the stuff just come naturally, and I never go back and check it out. When I do, I'm usually bang on. So anyway, I'm thinking, how the hell did this work? I couldn't figure it out. It took me about half an hour. Finally, it dawned on me. I see it there, and I see it there. If these are opposed.
So all these years that people have been that figured out how the Earth worked, it only took Lindsay 30 minutes. He's a genius.
To each other, mirror images. Why aren't they lining up? Because I was looking northeast.
You missed out on that bit, Farmer.
Oh no!
He all these years it's how long people took to figure out how the Earth worked and everything, and
Yeah.
it only took Lindsay 30 minutes.
Wow,
He's a genius.
he is.
Hmm.
I mean, he needs to get this work written down and peer reviewed and published. I mean,
Yeah,
Nobel Prize is just around the corner, surely.
I'm sure
Wonder what
Anthony would help him out with that.
Oh God! Yeah.
Wonder what Lindsay sees when he looks out between the bars on the window of his room. They got to have this guy locked up somewhere.
And if not, why not?
I
I
don't think,
was going to say,
I don't think we've seen him outside, so yeah, you might have a point there.
I think the only prize that this guy's going to win is a no-del prize.
Yeah.
So if I'm looking northeast, I'm not at my zenith, I'm looking off on an angle. So when it comes around to meet at my zenith, then they will both be directly in line, like this. So, I'm right. I'm not going to call my theory is right, because I know it's fact. That is a parabolic image of what's out here.
Yeah, there you go. You state something. You say I'm right. I'm right.
It's not right, but it's fact.
Yeah.
I should know. I made it up.
Yeah, exactly. Anyone can make shit up and agree with it.
Get Orion's bow, you'll see a small one, and then you'll see a big one out here. But I only saw them offset like that because it wasn't at my zenith. So if I was looking dead north and just waited for a particular time,
What,
they would
not
come across
northish?
and both be dead north to south to me on my zenith. They would line up. But anything that's not on the zenith, dead north to straight south over your head, they will be diagonally opposed to each other. The other stars I've noticed was Betelgeuse and Regal.
Betelgeuse.
Or Sirius, Betelgeuse,
Oh man,
Regal.
He didn't say that.
He did. He said it.
he did.
He didn't.
He did.
Oh, he did not.
That's Betelgeuse.
Oh,
Well, lucky he didn't say Betelgeuse.
Can't think. But you'll see Orion's belt like this at one point, and you'll see the cross is like this. You'll see, I think it's Sirius over here, won't you? Isn't it? I'm looking.
Well, you're telling the story,
north.
Lindsay. You
I'm
should
going to
know.
the south. And is that Regal? Regal.
Regal.
Betelgeuse. Whatever here.
Betelgeuse.
Diagonally opposed. This star is this star, and this star is this star. And if you get out with your camera, your P900, don't worry about trying to focus.
Why
It's
are
just all
you
BS. They just want you
P900?
to see pretty colours and what they want you to see.
Oh, the flat
But
earthers
zoom
camera
in,
choice, sorry.
look at it close, you'll find they are the same. And that will be the same as that. Okay? It's just more proof that this, what I'm telling you is right. Those stars are what's out here. It's parabolically
Not proof.
mirrored here because
I don't think he knows what the word proof means. not what you think it means.
With the flat sky in the northern hemisphere having the curving down here in the southern sky, this rotation creates this out here. Now, we can see them like this, a rotation and a rotation. When we look at the sky, they look like they're vertical, right? And then you bring it, but if you bring them down onto a horizontal plane, what are they doing? Exactly this, going off to the west. North comes out, goes to the west. South comes out and goes to the west.
Yeah, but which way are you looking, Lindsay, and where are you?
That wasn't mainly what the video was about. The video was about field theory, basically. I was just watching another one of Globebusters' videos. They put out, must have been last Monday. They've got Ken Wheeler coming on tomorrow. And they were showing a bit of Ken Wheeler's stuff on magnetism. And I just wanted to expand on a few things that they were talking about. So I've scribbled notes here. There's nothing planned here, sorry. Frequency and amplitude creates the pulsing. You've seen other videos, the pulsing of the earth, the tides, everything. There's the pulsing, that's the
tides, okay.
Driving the toroidal field, everything. Physics understands the 2 to 1, right? I've told you before, in other videos, the sun does 2 to 1 with the stars over the year, because the sun is racing ahead and laps them. Over the month, the sun laps the moon. But the dual creation of electromagnetic force, which is 2 to 1. Now, now this is a biggie. The electromagnetic force.
Did you just choke on his own words before he
creates the sun?
I think so.
2 to 1 creates the sun. Yeah. So the EMF meets the magnetic field at 0 point to create the inertial plane, the thin, instantaneous layer of rest between the two forces that seek rest.
Yeah, word salad.
Now that's in the terms of a 12-year-old, I would think. You see,
I hear what you're saying, and it sounds remarkably like
quantum mechanics.
blah, blah.
Blah, 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 blah.
Hey, you know in quantum mechanics they talk about the horizon, the event horizon. We can't see beyond the event horizon. What do you think this is?
Do they?
It's not quantum
What?
mechanics, you fucker.
What?
That's a black hole, you numpty.
Quantum. The event horizon's quantum mechanics.
Yeah.
Okay.
Yeah. Well, you learn something every minute. Yeah.
Have I explained that we're
With Lindsay, you unlearn something every day.
Yeah.
existed here.
Lots
We don't see what's in here. We can't get in there. No flights. No man can get to the place of
How do you know what's there,
inaccessibility.
Lindsay?
Yeah.
Well, now
Good point.
he's saying we can't fly over the North Pole.
Dead centre. We can't see what's going on in here. Well, quantum mechanics, they call this the event horizon. We can't see beyond this event horizon. They know theirs flat. They're just spinning it all differently for you. 'Cause everything they say correlates.
He does say there's a black hole in the back of the sun, doesn't he? So, you know. That's
No,
probably
no,
what
it's not in the back of the sun. Remember, the sun's on the edge of the black hole.
Oh, he moved it. I was remembering from an older one where he just basically said that the back of the sun was a black hole. But, you know, like you say, it changes every time he makes a
It
video.
does.
Yeah, it does.
Yeah, forget everything you've learned before.
And that's with the flat earth
Again,
system.
I'm particularly intrigued by the amount of knowledge he has about the contents of the vortex when he says so often, but we don't know what's in there. We can't see in here.
He's got X-ray dirt.
Yeah, it's a special knowledge.
Where was I going? Right. This is the biggie, folks. This is the force. This is how we get electricity. This is how we get the sun. This tropical gap here on Earth creates electromagnetic force. So we have a magnetic field, which is a snake and the infinity symbol that goes down, along, up, down, along, and back up here. That's the Earth's magnetic field. That's the infinity
How
sign
can you have
snake.
a field that goes through the same point in different directions?
Yeah, it doesn't work like that, right? They would
Yeah,
cancel each other out, wouldn't they, Alan?
Yeah, don't cross
They
the
wouldn't
streams.
be.
Don't
Cross
cross
the
the
streams.
streams.
And
No,
Can't cross it.
so we've got the magnetic field. So you've got a north, you've got a south and a north pole. You've got a north So you got a north here and a south. But you've got this gap here. And because of this gap, the field's there and there.
So I have to recalibrate my compass then. This is not going to point.
Hey, I hope. Sorry.
No, I was just trying to figure out how my compass is working. If Lindsay's asserting that.
Well, just as long as you've got a southern hemisphere compass.
It creates the EMF, electromagnetic force, which is the sinusoidal wave that goes down into this end. Down
And
through
if
this.
there's an electromagnetic force, wouldn't that cancel out all the rest of it?
To create the sun.
He just said something. Sorry, I'm going to say I'm sure he just said something that makes absolutely no sense when it comes to electromagnetic wave propagation. But no point in going back and listening to it because
No.
And the first magnetic field, which is a negative, comes up here. There's the choke point. That's the plane of inertia in there. So basically you've got this
Plane of inertia.
coming down, and you've got the Earth's magnetic field coming up. And bingo,
Bingo.
there's the plane of inertia. The point of equilibrium,
So what
where
happens
it
there?
becomes fixed and
Lindsay?
stationary.
Yeah.
That is the
What makes
Earth.
it a plane of inertia, Lindsay?
That's where the Earth is created, and we all dwell in here. This point of singularity, beyond the physical
Oh,
thinking
geez.
person, I know. But that's what it is. That's how it is. That's the EMF coming out of the tropics. This is the Earth's negative, or Earth's magnetic field. So when Ken Wheeler says basically electricity is a byproduct of magnetism and electricity, well, and it is because there's the magnetic field, and it's because of this gap
Huh?
Yeah,
you get the
exactly.
electromagnetic field, the sinusoidal wave here, which creates the entire spectrum. This wave of duality, this is like the dual system becoming one.
What?
2 into 1. There's a
Why
2
is
into
it
1 there.
sinusoidal?
This is like a big.
What's that up?
I said, why is it sinusoidal? Yeah,
'Cause
why
he
isn't it
drew-
a square one
Because he drew it
Or,
like that.
or a
He's trying
triangular?
slinky. He likes his slinkies.
He's trying to insert every buzzword he can think of in here.
Yeah.
I know.
I think he's missing a few, but he'll probably get there by the end.
Saying it's the Trinity is where all the magic is.
The
So
magic.
it's not just 1 and 2. You've got to understand that 2 fields creating 1, and another field down here, which that makes 3. But they come into they finish up as a dual system here. That's electricity. So to get electricity, we need this gap, don't we? It's just like in the magnetic generators. What do they call it?
Yeah, what do you call it?
Can't think. Late at night.
A magnetic
The gap
generator.
in the
Oh, God.
generators. Tesla's.
You doing a Riley?
Yeah.
No, see what
Yeah,
he
they
Pouring a drink now.
I heard something. I went,
2013 Cab Sav.
okay, is that coloured
shall.
water stuff?
Yeah. Yes, coloured water.
Coloured water.
I shall
yeah.
bid you gents adieu at this point. I've got to go.
Oh.
Okay, Blue.
Yes,
Uh,
something interesting, aren't you?
See you later.
Yeah, it's time to go move Cavendish. So
Oh, of course.
Oh,
Oh,
wow.
I got to get ready and get out of here. I'll see you guys later. Have fun.
Like-
See you
Later,
later,
Blue.
Blue.
Yeah, you
Bye.
too.
You can think, and what I've drawn here, it correlates with what Nigel Cheese has been talking about. How you create the free energy and all that. You understand this? You can start getting it. You can create your own free energy.
how?
It's already out there. Just takes a bit of thinking.
Is it?
Still working on it myself. I just haven't had time
It's out there.
to come up with it.
You just got to go and
But
get it.
that's it there.
How do I
So-
catch it?
I'm thinking. Well, it's the same system as the step-down transformer. Like, they take the transformer out of a microwave. What have we got there? The step-down or a step-up, and you've got the metal in between, which is creating the
down
gap.
a microwave or any other electromagnetic wave.
In his world, you can.
I'd like to see him pull apart a microwave and power it up and play with it.
Well, as it turns out, the biggest killer of idiots in America at the moment are those that are doing this, making fractal designs in wood by burning it with electricity.
Mm.
Yeah.
Yep.
Failing to correctly connect up the transformer. And of course, the transformer works in the opposite direction to the one that Paul suggested we were using in the quiz last week, and you get the voltage come out of it at the level I predicted because I got my step up, step down, back to front. About 5,000 volts.
Mm.
Oh, yeah, that'll do it.
Mm. Yeah, get a bit of a buzz out of that, wouldn't you?
Actually, I think it's even bigger than that.
Yeah, you've got both coils are isolated, right? You've got the gap, and they've used the metal as the gap to hold the magnetic field. So if they've taken a wire off that metal plate, and then you take it off get an earth. Not quite sure, I haven't got that in my head at the moment. To get your energy. Get your light. Get your power. Couple of points here. The sun is directional, not exposed 360 degrees. Science rubbish. BS. Full moon is at the back of the sun.
Yeah, that's right, it's BS.
Not opposite.
Not wrong there.
Behind the sun. The sun's direction is that way. The full moon is behind it, back here.
Nice.
Over
Like
there.
gravity is a hybrid. It's a dielectric. It is mass, i.e. matter, is a dielectric condensate. Well, gravity.
I'd like to know what state of mind he's in when he's actually writing his notes down originally.
Yeah.
No better than he is now.
Yeah.
There's this force here. Well, it's not really a force. Not a force, I wouldn't call it a force. We're just pressurized into this place of inertia here. Nothing's forcing you. It's just it's the big vortex in the center here. Magnetic field coming up here. It's just pressurized, and we're in this pressurized zone. And it gets weaker as you leave the Earth. You start falling apart, don't you? The human, if he goes up high, starts falling apart. Starts coming out here, you'll start falling apart. North Pole, now South Pole. Even when you go right to the North Pole,
Well, it's the
start
South
falling
Pole,
apart,
isn't
actually. Because we dwell out here, don't we? Out here.
Why is it called a South Pole, Lindsay?
So there you have it. It's gravity is this. I suppose you call it force. Well, it's the word they use, isn't it? But there's no pressure. There's nothing forcing you. You are just held there. It's like suction, more like suction than a force. Suction from the centre.
Suction's not a force.
Fixed and stationary to the earth.
got
We're
sucked
all
in
fixed
again.
to the earth.
Fuck, what is he on about?
Lindsay got sucked in.
12-year-old understand that?
Oh, yeah.
So,
sure.
0 point. Either pressure
Isn't
release
suction just a
creates
force?
our toroidal centre. Yeah, boom. So you've got to think, you've got this field coming in here, you've got the field coming in here, you've got a field coming out.
Pardon now?
You got toroidal and theta into one sentence there.
Well,
There's always a counter force. So you've got the spiralling in from the tropics here. At the same time, you've got
yes, TT, we can have a pole. I don't know how to do that.
the magnetic field coming out. And even in physics they say, you know, if you've got the sun here, they say it doesn't all go into the sun. Some goes into the sun and then some goes past. That's basically what's happening. And then out of there it creates our toroidal field. It's this rotation here, spiralling out. And you know, this is why Ken Wilber says there's nothing straight in nature. And there's not, because it all spirals out from the centre. It's a toroidal field. It spirals out.
Welcome to the Ken Wheeler
That's
fan
what
club.
creates the run line. So it comes out like that. And there's your tropical gap, and there's your southern field out here. Centre north. This is the run lines.
No, you can have a pole,
It's the
TC.
sun.
I just don't know
This
how
is
to
what
do
the
it in
sun will
side
do. Follow
chat.
this magnetic field, like this. It's not probably not quite like that, but like that. So the sun, anywhere around here will be the same time of the day on that big curve. Like if you take Eastern Standard Time up here on the east coast of America, let's say it's there, and look, you come all the way around. Oh, you come all the way around here. Oh, that's different. Okay. Yeah. No, I was going to. Well, it equates to the same time right around here in New Zealand. You know, because the sun's field is around here like this. I've mentioned that in earlier videos.
Wow.
Toro flux is what Ken Wheeler was using to show. It shows you our toroidal field that flows over the earth.
Okay.
Electrical field value and the magnetic field value. So what we have here is the electrical. Basically this is the electrical field. And then we have the Earth's magnetic field. So this created EMF electrical field hitting the Earth's magnetic field. That's what creates the sun. Bingo. You've got to realise what's happening back here in the centre is non-physical. We do not see it, we cannot see it, but it's put out here in the tropical zone as signs. So that's all reflected out to here, or been exploded out to here. So it all projects from the centre like a clock hand coming around the Earth, but it spirals out from the centre and shows us the picture out here within the tropical gap. So get your head around that. What you see in this tropical gap is what's shrunk back to nothing, 0 point, singularity, right back here in creation. Just like the human brain, a thought become manifest.
TT to guys trying to
That's
set
what
up
it
a
is.
pole out there.
So work on what you're seeing here, we'll come back from in there. And you see, we see things in arcs.
Yeah, not
Like if you're in the north looking south, it's coming from the east around to the west. There's an arc. We're in the south, we're looking north. Things come around in our arc, go over us in an arc. We don't see it coming from around here, we just see this arc. Well, you know, you don't even really see that arc, except it's a bit more obvious at the solstices, where it's curving back like
Alan.
this. But basically this is what's happening. It's coming out of the north like this. That same thing is way back here. This is all related to why they tell you you live on a spinning ball. Look, it's way back here, same. Reduces back. Tried to explain that, it's a bit complicated. What else we got? We have the magnetic field direction, but the stars, right. We have the magnetic field. So we have a magnetic field, so it spirals out like that's the magnetic field, right? That's the centre, it's the northern hemisphere. Spiraling out like this is the run lines. That's the toroidal field, that's what spirals out, it comes out of the centre, out of the vortex, flows around the world. We have a magnetic field, but then you have the stars, which are projections. So don't start thinking that the stars are in the magnetic field.
Where are they?
They are reflected into the magnetic field. And
What?
as this turns, with the stars in it, the picture's turning out here.
So they're just an image projected into
So the
the...
stars are all projections
sky.
from right in here. They're projected up from in here, up to the northern hemisphere sky, revolve around the north, around Polaris, and then they're parabolically imaged out to the south.
Exactly.
So we have the magnetic field direction, but the stars are not the magnetic field. They are reflected into, the magnetic field. So they are 180 degrees diagonally opposed in a parabolic show. because of the curving down of the southern field.
There you go.
Ah,
Huh?
my, doesn't 27 minutes and 13 seconds at 1.25 actual speed fly by?
Doesn't it?
I got a headache for some reason.
Wow.
At least I have a cup of tea now.
Cheers.
Although I don't have any milk in it because like the milk went bad.
Oh.
and I didn't bother to get any out bother to get the bottle out of the freezer last night because I'm supposed to be getting my shopping delivered sometime today.
I thought when I went downstairs to make a cup of tea, I thought that's handy. That's an Amazon van outside. That must be my delivery because it's about that time.
Yeah.
He delivered to somebody just across the way, and then I looked on my phone, and yeah, now it's anywhere between 5:15 and 7:15 this evening. It's like, but you
But you're already there.
You're here.
Yeah.
Different van, mate. Different van.
Must be. But I thought, he's here. It's about the time. It was going to be anywhere between, I don't know, 12.
If we know somebody that worked at Amazon, well, they should know what the procedures are for their delivery.
I don't know. I don't work at Amazon.
Well, if we knew somebody who worked at Amazon,
I design stuff for them.
but if we knew somebody that worked there that may have known.
used to work for them.
Yeah, I did used to work for them. Now I do sort of work for them, but only in a consulting capacity.
Yeah.
I haven't been able to say that for a few years.
No. Oh, I'm getting a notification. I'm live. Okay, we can start now.
Oh, thank God for that.
Yeah.
What do we always start with? We always start with a Lindsay.
Yeah.
Yeah.
Hey, at least we're going to get to rebuild our grandchildren now, doing some simple O-level physics.
Oh, not quite yet. We've got one video to do.
Okay.
I'm sorry, it's a Saturday. I don't do that on Saturdays. In fact, I don't do it any time at all if I can avoid it. I had a set of drawings yesterday that I had to go through and make comments on. That was difficult. That's some of the best drawings I've ever seen.
Not.
Oh, the one of the contractors was using for these stores. I was told that they're really good. They're the guys who I met down at Seven Oaks the other week, and you're supposed to check it. You do it all online. It's all there. You can make red line comments. But I thought, no, I'll print them off. It's easy to look at. It's not on an A4 drawing.
Oh,
I'm looking at them thinking, I can't find anything to comment on. These are some of the best drawings I've ever seen. I found a couple of things in the end, but it really was a case of, shit, I can't just sort of say I've got no comments because I was double checking. Have you coordinated this with that? Yeah, I've got to hand it to them. They know what they're doing.
You've been printing out any more random pictures?
Well, I don't know about random, but I do have the outline of what was a NatWest Bank in Victoria Street because that's where I'm going on Monday. We ain't got bugger all drawings. We're supposed to go to the place and survey it. It's like, well, how? You haven't given us any drawings. I've just got one. It's crap.
Carl said he's I'm going to be starting in 30 minutes. So do I start now or in 30 minutes? I don't know.
I've got time to go make another cup of tea once I've drunk this one.
Well, I've played this one because this is the Arctic Reflections
Arctic
take
Reflections.
on. Yeah, we'll watch that. It only goes for 7 minutes.
Oh, that's handy because I haven't had a chance to watch this yet. So.
Does it need to be on normal speed?
Yeah.
Yeah, normal for. I don't think it's. You might want to place it.
Okay. Press yeah.
Yeah, that one.
No. Oh, I don't know. Oh, I don't know what sort of music that is or whatever.
Hibler Production have released a new Flat Earth movie. This one is called the next level. And I think it's rather the next level of stupidity. This will be a short video. I chosen one of the many lies in this video.
Oh yes, yes, doesn't he?
First of all, I want to thank all my patrons, members, donors and subscribers. All of you are important for me. Thank you very much.
Oh yeah.
Most in this movie is reused garbage from different Flat Earth channels. The same argument that we hear over and over again. But this one was a new one. Let's have a look at the short part of the video.
They don't let anybody explore Antarctica.
Bingo. I'm going to yell bingo for them. That's too loud. This is going to be music.
Weren't they? That's very dramatic.
No, it's nothing. It's just music. This is not going well.
No.
You better not get too close to that warship, mate. You know what'll happen to you.
This was presented as if they were being turned away from Antarctica, which they're clearly nowhere near Antarctica.
No, it's the actual ship.
They did work out where they were. They were just off the coast, and they were straying into an area where the Navy were doing exercises.
Yeah.
And that's why they're being turned away, so they don't get accidentally shot. It's got absolutely nothing to do with that. I mean, that is not the Antarctic, you know, you can tell.
Where's all the ice? Yeah.
They'd be freezing their bollocks off by now, you know.
Yeah. I mean, after all, it did say Bass Strait at the start of it, didn't it?
Exactly. So it tells you where they are, and then they're pretending they're being turned away from the Antarctic. Look, the Navy are turning us away. Yet you're not anywhere near the Antarctic.
Bass Strait's the bit between mainland and Tasmania.
Tasmania,
yeah, exactly. That's where they are. You know.
What's the? I was just wondering what the name of that strait, or what they call that area below Tasmania in the Antarctica then.
What, between Tassie and Antarctica? I believe that's called the Arctic Ocean, isn't it? Sorry, and Southern Ocean even.
Yeah, I'd have to Google that. Have we got sound?
And there we did have another information that the team behind the next level didn't want us to see. It's the coordinates of the place where they met this destroyer. Let's have a look at where this location is.
Have a look where that actual location.
Bass Strait is the sea between Australia and Tasmania, and the coordinates, it's confirming this. They were quite close to Australia. Another thing that confirms that is the type of boat they're using. It's a very small boat. It's nothing you're going to Antarctica in. But according to the Flat Earth clowns making this silly movie, it was because they was too far south. But south of this location you have Tasmania. So is it forbidden to visit Tasmania too? Of course not. The explanation
you're not allowed to go to
is much
Tasmania.
simpler.
Oh yeah, you don't want to go there.
The warship called up bad boys on the radio and informed them that they were in a restricted maritime zone. Everyone with a little knowledge and experience of being out at sea do understand what's happened. This is one of the things I'm doing in my line of work. If we have exercises with the Navy, we can close a part of the sea, and information on that you can get on proper channels, and it's you as a seafarer who are responsible to look if an area is closed or not. In those scenarios, I often operate a small fast-going military craft and are contacting ships or boats getting into the danger area. What the destroyer is doing in this area can be secret, but perhaps it's a shooting exercise. They can shoot with their cannons, placing out mines, shooting anti-ship missiles. You don't want to get in the line of fire in a small private boat. And the Navy have no interest in shooting at small civilian boats either. Those flat earth clowns did find the video on YouTube, and they made their own story about what we were seeing.
It's TT guy implying that Mr. Arctic didn't say that Tasmania was part of Australia. I don't know, I might have missed that bit.
In this video, this is lying, and deceiving their audience. It's typical flat earth. This was a short one. Hope you liked it, and I want to thank Steve B, who did make a super thank on the last video about Eric the Bay. I will be back next week with more videos. Have a nice weekend all. Bye.
Okay. Well, that was an easy one. So if that's this level of wrongness they've got in it, well, it's only going to go downhill from there.
And you notice that the Flurfs didn't give the location correctly?
Of course not. We don't actually want you to know where they are.
Because, you know, only got the sign wrong. Only got the sign wrong on the latitude.
Ah,
didn't it?
There we go. TT said Mr. Arctic Reflections said they were between Australia and Tasmania. Yeah, I know his English might not be great. He might have meant the Australian mainland.
That's what he meant, mainland Australia.
He should have said,
Tasmania.
he should have said mainland Australia. And
it wasn't that long ago that he wasn't even using his own voice because he didn't think his English was good enough.
Yeah. Well, that's all he's missed out on. Mainland. He didn't say mainland Australia and Tasmania.
Tut tut.
Yeah.
That's an understandable thing. Yeah.
Yeah.
I mean,
I wouldn't pick on him for that.
In general conversation, or would you just say mainland?
I don't know. It doesn't usually come up much in conversation.
Yeah. Tasmania never comes up much in conversation.
TT goes Bass Strait or something.
Yeah, it was. That's where they were. They're in the Bass Strait.
Yeah.
But they were trying to pretend they were getting close to Antarctica.
I take 1 point off. TT guy's taking 1 point off. If you want to say anything, TT, you can just jump into voice chat in Discord and they can hear you in here.
I mean, clearly they were in a boat that didn't have enough fuel to actually go to Antarctica.
Yeah, they weren't exactly dressed for it either, were they?
No.
I mean, that's fine if they were Geordies from the UK. That's exactly how I expect them to dress to go to Antarctica.
Yeah,
because they're completely impervious to cold weather, obviously.
Yeah, right.
Oh dear.
Oh dear.
Oh, it's true what they say. You got to lie to Flurf. We were stopped going to Antarctica. Well, no. You were going fishing.
yeah. So, that's 38 degrees. Not 38 degrees north.
Yeah.
Well, I got stopped going to Perth the other day. I mean, the police pulled me up and, you know, I wasn't actually going to Perth, but it makes a good story.
Exactly.
I could have been.
I was going that way, you know.
Yeah, I was heading in that direction.
Yeah. Oh, it's...
Where you guys are down in Melbourne, you only got to go around the corner and you hit South Australia. It's a state you drive through between where you are and Perth.
Blimey, that's a big glass of vodka you got there, mate. Dear
And make him spill it all over his keyboard now.
No, he waited. He did at least have this and wait.
Yeah.
I'm not going to do it when he's mid-swig because I just go.
It'll come out his nose.
Christ, that's dedication to the cause. I mean, I used to drink it by the pint, but at least it was mixed with something else first. Bloody hell.
Ozzie Baller managed to make me blow tea out of my nose one day.
Oh, no, that's very impressive.
He timed it just, I wasn't on video. Unfortunately, I wasn't on video, but he timed it just right. And tea over the keyboard via the nostrils.
Yeah.
Dorf said, "What did they ask you, Paul? What's with all those ducks?"
Ducks.
Oh boy.
Okay, what are we up to?
Well,
We're done with all that. Yeah, we're done with that.
you want some physics, hey?
Oh,
Well-
yeah, let's get the.
Well, I'll go and make.
No, frankly.
Is it time for me to go and make my coffee now? Okay.
Most of these questions are at the level you would find in the UK on an O-level paper. So
Yep,
At
that'd
the
be
age
about
of
right,
16.
Alan. Yep.
Oh, that leaves me out.
the last couple of what you'd get on an A-level paper, which is 18. usually for university entrance.
Yeah, that'd be about the same level here in Australia. I mean, these are all questions roughly from a final year in high school level. Yeah, what they call VCE, Victorian Certificate of Education level.
Yeah.
So round about that, but you know, I'm more interested in a discussion about the actual principles involved here rather than an actual calculation of the answer. You know?
Yeah.
It's what you think about it, how you think about the physics that's actually there that really matters. You know, I know you're finding it hard to think right at the moment, but
Indeed.
you know.
Sorry,
all that mechanics going on in front of me.
Yeah, yeah. All right, so let's lead off with a question then. So, in this example, we've got a bushwalker, all right, and while walking, search and rescue officers drop an emergency package from a helicopter to the bushwalker. They release the package when the helicopter is at a height h above the ground and directly above the bushwalker. The helicopter is moving with a velocity of 10 metres per second and an angle of 30 degrees to the horizontal, as shown in Figure 1. And there's Figure 1 for you. All right. The package lands on the ground 3 seconds after release. Ignore air resistance in your calculations. So this is the typical sort of high school question where you ignore air resistance because that just complicates things way too much.
Much easier, doesn't it?
It does make it much easier, yeah. That's right. You know. So you can see the diagram there. You've got the helicopter travelling upwards at an angle of 30 degrees at 10 metres per second, and it releases a package, and the package will take a parabolic curve until it hits the ground. And the question they're going to ask you here is, let me go back one there. So the package lands on the ground 3 seconds after release. Ignore air resistance in your calculations. I think you're asked to actually calculate here what the height of the package is before it was released.
That wasn't what I saw in the questions earlier, Paul.
Yeah, I've obviously missed that part in it. So the question is actually, what height was the package when it was released, and how would you figure this out? Got any ideas for how you might sort of attempt to attack a problem like this? Any ideas?
I can't remember any of them. What?
And one of the things that we do a lot in physics is we resolve the motion into different directions, and the convenient directions to resolve the motion into here are the horizontal motion and the vertical motion. And the reason why we do that is because gravity acts entirely in the vertical dimension and not in the horizontal direction. And so by taking those two dimensions, we can predict what the motion will be in those two dimensions and allow us to do some calculations. So thinking about it in the vertical dimension, we can see that the package is going to rise up a little bit and then stop rising up because gravity is pulling it down.
Yeah.
And then it's going to accelerate downwards until it hits the ground. And so we can use some basic fundamental Newtonian mechanics or principles of motion to allow us to do some calculations here. All right? And one of the calculations we can do is how long will it take for it to reach the top of its motion? To do that, we need to know how fast it's going in the upwards direction in the first place. Any idea how to do that?
That would be 10 sine theta, which is 10 sine 30 degrees.
Yep. Anyone know what the sine of 30 degrees is?
I should do, but I have to calculate it with it on it here.
Yeah.
Sine 30. I'm in degrees this time, not in something else. Well, it's 0.5, isn't it? Of course it is.
And it's a half, yeah. So sine of 30 degrees is a half. And so the package is rising up at half the 10 meters per second, which is 5 meters per second in the vertical direction. Now, if you take the G as 10 instead of 9.8, which they often do on these type of questions, just to make it really simple, you should be able to calculate how long it will take to actually reach the peak of that curve. So starting with an upwards velocity of 5 meters per second, how long would it take to reach the top of that curve? How long would it take for velocity to become 0 in that vertical dimension? So to do a calculation like that, you use something called the constant acceleration equations, and you know that the initial velocity is 5 and the final velocity is 0, and the change in velocity will be given by the acceleration multiplied by the time. All right, and so you can see there the equation 0 equals 5 minus 10 times t. All right, because 10 is the acceleration due to gravity, and when you rearrange that equation you get t equals half a second. So it's going to take half a second for it to reach the maximum height, and then it's going to take another half a second for it to come back down to its original height. And that leaves a total of 2 seconds for it to fall from from that height to the ground. And then we can calculate the distance by using the constant acceleration formula again to know how far to travel from that height to the ground in 2 seconds. And the equation you use there is that h equals the acceleration times the time plus half times the acceleration times the time squared. All right? So the initial velocity times the time is 5 times 2, which is 10 meters. And then half times 10, which is 5, times 2 squared, 4. 5 times 4 is, so it's 5 times 4 is 20. And I think I've got that calculation wrong there. So it should be half times 10 times 4. That's right. So 10 times 4 is 40. Half of that is 20. Plus the 5 times the 2 is 10. That should be 30. So the answer should actually be 30, not... I don't know why I got that wrong. I forgot to put the half in that equation down there. So the answer should be 30, not 50. So sorry for that mistake there. But the answer should be 30 metres above the ground.
Yeah.
So 30 metres above the ground should be the answer there. Yeah. The second part of the question, yeah, Alan?
Like I said, that was the bit of the question we never got to see.
Yeah, that's right. Yeah. Yeah, and I made a mistake there because I forgot to put a half in. So the answer should be 30. Not 50.
Though, isn't it?
Yeah, that's right. Yeah. Now, this one here is a sort of a fairly intuitive one, and I think most people would be able to answer this one anyway. So assuming that the helicopter continues to fly with its initial velocity, where is it when the package lands? Which one of the statements below is most correct? So will the helicopter be directly above the package? Will it be directly above a point that is 15 metres beyond the package? Will it be directly above a point that is 26 metres beyond the package? Or will it be directly above a point that is 30 metres from the bushwalker? What are your thoughts here, Alan?
Well, I just know what the answer is.
Yeah, what is the answer?
The answer is A. Because
why?
Because the again, we resolve into vertical and horizontal.
Yeah.
Okay. We're only interested in the horizontal this time.
Yep.
And there are no forces on either the package or the helicopter because they're all going at constant velocity in the horizontal. Yep. So therefore, the helicopter will always stay directly above the package.
It will indeed. That's right, because in the horizontal direction, there are no net forces acting because it tells us to ignore air resistance. So the package will quite happily go along at a velocity of 5 metres per second, right? Yeah. Or actually, it'll be a bit more than that. It'll be
10 cos 30, won't it?
8.6 metres per second, I think. It's root 3 on 2, isn't it? Yeah.
I'm sorry, I can't remember what.
Yeah, it will. It's the cos. It's the cos of 30, which is.
I haven't had to use this stuff for like nearly 30 years, so.
Yeah. Yeah, I'm pretty sure it's the cosine of 30, which is root 3 on 2 times that, which will be 8.6 roughly meters per second. But the helicopter's going in the same direction horizontally with the same velocity horizontally. And so it will stay directly above the package. Yeah, and that is indeed exactly what happens. In the information given, we were told to ignore air resistance. This means that the horizontal component of the velocity of the package will remain constant. Thus, the helicopter will be directly above the package when it lands. Yeah, so A was the correct answer. Okay, next question. Which of the graphs below best represents the speed of the package as a function of time? And note very carefully here, they say the speed of the package. Okay. Yeah. So which of those graphs you reckon best represents the speed of the package? What do you reckon?
Well, I reckon that you can remove A and B straight away.
Why?
Well, because we're releasing the package upwards. And so its speed has to reach 0 at some point before it can start falling. So
okay, I'm going to pull you up there, Alan, because it will reach zero in the vertical direction. But what about the horizontal direction?
It's still moving horizontally, isn't it?
Yeah.
It's still moving horizontally, Alan. So it's still got some speed there, right?
Oh, bugger.
Oh, bugger. Yeah. All right. So which ones are we eliminating now, Alan?
We're going, all right, let's quickly eliminate C and D then.
Yeah, we're
I think
eliminating
so.
C and D because clearly the package never reaches a speed of 0, all right, because it's always got that horizontal velocity. You're right about that. Farmer's Boy even picked that one up. Well done. All right, so now you've got to choose between A and B. Which one are you going to choose and why?
Well, we know that it's undergoing constant acceleration.
Yeah.
So the acceleration will be, and we know it's going through a parabola in time. I'm going to say it's got to be B because A has got a variable acceleration on the downward part.
Okay, it's think about it. Seeing as the horizontal velocity is constant, that's not going to really enter into it much here. It's mainly going to be the change in speed in the vertical direction that's going to affect the change in speed here anyway, okay? So think about it, that after it, we would expect it to be symmetrical about the point where, you know, it goes up and it comes back down to the same level. But then beyond that point, what's its speed going to be doing as a function of time? So in the first second, it's going to go a certain distance. And in the second second, it's going to go a lot more distance. Why? Because it's accelerated to a higher velocity. It's now going faster. It's getting increasingly faster at an increasing rate. Okay? And so we would expect the graph to look more like B than A. Because A is sort of like indicating that the speed, although getting faster, is slowing down in its rate of getting faster with time. Whereas B is showing a graph where it's getting faster and faster at an increasing rate.
I think that's what I was trying to say. I just got my words really confused.
And here's what I've written here. I said we can eliminate C and D because these show the package reaching a speed of 0 at some point in time. This is not possible because the package will always have a non-zero horizontal component of velocity. Having eliminated C and D, we now turn our attention to A and B. Graph A shows the speed decreasing and then increasing as we expect. However, we note that with increasing time, the speed increases at a slower rate, which is not what we would expect if we were ignoring air resistance. This leaves B as the correct answer. There you go. All right, so here in question 4, we have a car of mass 1,000 kilograms travelling on a smooth road at 5 meters per second, and as it does in all these sort of problems, it collides with a truck, right? That is stationary at a set of traffic lights. After the collision, they are stuck together and move off with a speed of 2 meters per second. How much momentum did the car transfer to the truck? What physics is involved here?
Conservation of momentum.
Yeah, conservation of momentum. And what does that mean?
That means that the total momentum before the collision must equal the total momentum after the collision.
Okay, correct. And how do we calculate momentum?
Mass times velocity.
Yep, in the old Newtonian mechanics, momentum is equal to mass times velocity. So before the collision, the momentum of the truck was clearly 0 because it was stationary.
Yeah.
That means the momentum was entirely of the car. So the car's momentum, its mass being 1,000 and its velocity being 5 meters per second, means it has a momentum of
5,000.
5,000 kilograms meters per second, right?
Yeah.
Yeah. And so the momentum must be the same after the collision, which means that together, both the truck and the car must have a momentum of 5,000.
Yeah.
So we know that whatever the mass is, we have to multiply that by 2 to get 5,000. In other words, what number do we have to double to get 5,000? Yeah?
2.5.
Not 2.5, 2,500.
Sorry, yes.
Yeah, all right. And so that's the mass of the combined truck and car. But if the mass of the car is 1,000, that means that the mass of the truck must be
1,500.
1,500 or 1,500 kilograms. Yes, and that's exactly what I've written in this little spiel here.
Yeah.
Okay, so using the conservation of momentum, we can calculate that the truck must have had a mass of 1,500 kilograms. Good. So we go onwards. What is the mass? Oh, so what is the mass of the truck? We've already done that, yeah. Okay. What did I ask before? Yeah. Oh, yeah, okay.
I think
yeah,
you've got the answer to another question at the bottom.
Yeah,
there.
I did, yeah. Yeah. How much momentum was transferred to the truck? Well, after like that was the previous question, after they collided, they were travelling at 2 meters per second. Right, so the car was travelling at 2 meters per second, which means 2 times 1,000 is 2,000. But it originally started with 5,000, so it has lost 3,000, which means that 3,000 must have been transferred to the truck. That's essentially what that question was, and we've already answered this one. So that's 1,500 kilograms. Right, if the collision took place over a period of 0.3 of a second, what was the average force exerted by the car and the truck? Any idea how to do this one?
Well, I'm going to find the average acceleration first, and I'm going to assume constant acceleration.
Okay.
So
see what answer you'd come up with here. Yeah.
So of course the delta V is 2 meters per second. Delta T is 0.3. So 2 over 0.3 would be the average acceleration. Then I'm going to stick that into F equals ma, because we know the mass.
Yeah, you're going about it a bit of a complicated way here, Alan. I think Dora's already onto the answer out there. All right, so what we're going to think about here is a thing called impulse, all right, and how you change momentum. Momentum can be changed by applying an impulse to an object, okay? In other words, you exert a force over a period of time on an object, it changes its momentum, and that force multiplied by the period of time is equal to the impulse. It's what we call an impulse, okay? And the impulse is equivalent to momentum. It's just calculated in a different way. The impulse is force times change in time, all right? So we know that the impulse must be, we gave 3,000 to the truck, all right? And that happened over a period of 0.3 of a second. So if we divide 3,000 by 0.3, we get exactly what Dora predicted out there, which says 10,000 or 10,000 newtons or 10 kilonewtons. Well done, Dora. You are killing this.
Yeah, I will say that my answer does also give you 10 kilonewtons, but
good.
You know.
Yeah, it's just a complicated, long-winded way of doing it.
Hey, it's been a long time, and this bit is used less than having to worry about F equals ma and stuff like that. So
yeah, that's
I stuck with what I could remember.
Yeah, and here's the two questions that I thought Terry would be able to do as well. Right, so a train is travelling at a constant velocity on a level track. Bev is standing on the train, facing the front, and throws a ball vertically up in the air and observes its motion. Describe the motion of the ball as seen by Bev. What do you reckon? Are you there, Terry?
Yeah, I'm here. I'm just thinking about this one because I have seen examples of this.
Yeah. So if Bev is standing on the train, right, and the train's moving with a constant velocity, and he throws a ball up in the air, what's he going to see the ball do?
Is he inside the train or on top of the train?
Yeah. No, he's
Oh,
inside the
he's
train.
in the train.
Terry. He's not a knobhead.
If it's the Bev I'm thinking of, can he be on top of the train?
Yeah.
Oh, what do you mean?
And notice it's on a level track.
Yeah, it's level. It's horizontal.
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 So we
What's
just
he going
want
to see the ball do?
So
Terry?
the motion is described. It's vector and direction and.
Just by Bev, what's he going to see the ball do? From his point of view.
Yeah. I'd say it's just going to go straight up and then straight back down again.
And you'd be right, Terry. Absolutely 100% correct. So from his point of view, it doesn't matter whether he's moving at a constant velocity or not. From his frame of reference, he might as well not be moving at all.
Yeah, I was thinking.
And so the ball is just going to, it's just going to go up and come straight back down and land in his hand. All right, so that's exactly what's going to happen. From Bev's point of view, he will see the ball move straight up and then after reaching the pinnacle of its motion, comes straight back down into his hand. From Bev's frame of reference, he is stationary. Okay. And then the second part of this question is Nathan, who is standing at a level crossing, sees Bev throw the ball into the air. Describe and explain the motion of the ball as seen by Nathan. So what's this guy going to see? He's external to the train and he sees the ball being thrown by Bev, who is inside the train, moving at a constant velocity. What's Nathan going to see the ball do?
Still go up and down.
Still going to go up and down, but is it going to go straight up and down from his point of view? Because if it went straight up and down, then it would land or come back down in the same position that it left. But does it do that from Nathan's point of view?
You'd think it would because it's moving with the train, and Bev's moving.
Well, think about it, Terry. If it happened to be going past like at a level crossing, right, and right when it got to the level crossing where Nathan was, Bev threw the ball up in the air. Where would the train be when the ball came back down into Bev's hand?
Yeah, the train's gone past him with the ball with Bev.
Yeah, so the ball's in a different position, according to Nathan, isn't it? All right? Because from his point of view, the ball's no longer at the level crossing. It's now further down, past the level crossing, right? So the ball can't have gone straight up and straight down because otherwise it would be back in its original position. But it's not, because when Bev threw it up, he was at the level crossing. But when the ball came back down into his hand, he's not at the level crossing. All right? So the path taken by the ball, according to Nathan, is not straight up and down. It's in fact a curved path. It follows a curved path through the air as the ball goes up, travels to the left or right, depending on which way the train's going, and then comes back down. It's going to take a curved path. And in fact, that curved path is going to be a parabola. Okay? So what he sees, from Nathan's point of reference, Bev is in motion. He has a horizontal constant velocity. When the vertical velocity of the ball is combined with the horizontal velocity, a parabolic motion will be observed. So he sees it going in as the flat earthers say, a parabola.
Not a parabola.
A parabola.
Parabola,
Yeah.
And I've typed in what I think would be the equation for the parabola, but I could be way out.
Yeah, that's right, Zebulon. If he was on the level crossing, he's going to get hit by the train.
Yeah. Fair play.
Yeah, that's right. Yeah. Oh man. For some reason I can't see
In the
this.
chat, I stuck it in the chat as a DMTU.
This one here, I'm missing the first few words because I've got something covering it at the moment. It's basically a van towing a car, right? So the van, a car is being towed on a level road by a van of mass 2,000 kilograms, and the car is of mass 1,000 kilograms, right? There is a constant force acting on both due to air resistance and friction of 500 newtons on the van and 300 newtons on the car. The vehicles are travelling at a constant speed, which means they're not changing their speed. What is the magnitude of the force driving the van? What do you reckon? How would you calculate this?
No. There's no acceleration.
No acceleration, which is what the word constant means. Yep.
So the sum of the forces must be 0.
Yep. Absolutely correct. Yep.
Now we have a 500 Newton force and we have a 300 Newton force, both acting in the same direction.
Yep.
So we can simply add those together.
Yep.
Which will be 800 newtons.
Yep.
So and that is as far as the vehicles are concerned a retarding force. So the force in the opposite direction must be 800 newtons.
Absolutely correct. 100% right. All right. So if I can get my answer up. Yeah. The combination is travelling at a constant speed, so that means the forces acting are in equilibrium. The forces must balance. The forward forces must balance the backward forces. This means that the driving force of the van must be 500 plus 300 equals 800 newtons. That was too easy. All right. The next question is what? I can't freaking read this because it's...
What is the value of the tension T in the tow bar?
T in the tow bar.
Yeah. So what tension force is in the tow bar? What do you reckon? How would you calculate that? There's the diagram again.
Well, again,
would it be the mass of the vehicle times the resistance force? Or not times, but...
Well, it's something to do with the resistance force. I mean, how much resistance force is acting on the car, Terry?
It says 300 there.
Yeah, so what do you need to overcome that?
You need at least 300 plus.
Well, you need 300. Because if you had 300 plus, that would mean that would be accelerating, because you'd have more than enough to overcome that retarding force, which means you'd have a force in the forward direction, which means it would accelerate and increase speed. But because we're travelling at a constant velocity, it means that there's just enough tension to counteract that 300. So that means that it must be a tension of 300 newtons there. Okay? Make sense?
Mm.
Good.
Mm.
I don't know how I've got that. Let me just do that again. why I've got that that bit above there. I don't know how that got there for some reason. Don't know. Okay, so in this part of the question, they're travelling at a speed, I think from memory it was 15 metres per
15
second.
meters per second.
Yeah, and the van driver stops the engine and the van and the car slow down at a constant rate due to the constant retarding force acting on the vehicles. How far will the van and car travel before coming to rest?
Yeah.
So what would you think about here?
Well, I wanted to use the equation S equals ut plus a half at squared.
Mm.
So I figure out what the acceleration will be.
Yep.
And I've got the mass of the vehicles and the force involved as well. I then used F equals ma. Hang on. So I ended up with the acceleration being essentially minus 0.26 meters per second.
Hmm.
Oh, and also using the constant acceleration. So using the constant acceleration, I was able to find out how long it takes to go from 15 meters per second to 0.
Yep.
So now I have A and I have T and I have U. So I can plug it all into S equals ut plus a half at squared.
Yep.
And I can come up with 421 meters.
Okay, let's see what I got. All right, here's the way I did it. So how far will it travel before coming to rest? We need to calculate the acceleration acting on the combination after the engine stops. To do this, we used Newton's second law of motion, F equals ma. Yeah, well done. So with a force of 800 newtons and a mass of 3,000 kilograms, then the acceleration will be 800 divided by 3,000, which is 4/15 meters per second squared. All right, so then you can use that with the constant acceleration formula, and I used v squared equals u squared plus 2as because that includes our v, our u, which we both know, 15 and 0, and we know the acceleration now, which is 4 on 15, and when we plug those numbers into that equation, we come out with a value of 421.8 meters, which you round up to 422 meters.
Okay.
I'd accept your answer quite willingly, Alan. Well
yeah,
done.
I think
Yeah.
for some reason I ended up with 421.3.
It depends on how you
around
round
there.
off your intermediate calculations, Alan.
Yeah,
Yeah.
I probably did because I just fudged it
Yeah.
all into calculator and
Yep. No, I'm impressed with that answer. That's very good. Well done. All right. So here, the Earth is in circular motion around the Sun, and its radius of motion is 1.5 times 10 to the power of 11 meters. See figure 3, which is that. Oh, that's a cartoon. In
Not
what
even
direction?
CGI, blimey.
Yeah, bloody CGI. How can we trust that? In what direction is the acceleration of the Earth?
yeah. So this is where you start to go from O level to A level.
Yeah.
Yeah.
So here, the Earth is accelerating, and here we're using a different sort of concept of the normal understanding of what acceleration is. I mean, normally when people think of acceleration, they think of things getting faster or slower, all right? Normally just faster. Deceleration, things getting slower. But acceleration is actually more than that. acceleration can also be a change in direction, which means you don't have to actually make the thing that you're accelerating go faster or slower. All you need to do is make it change direction. So which direction is the acceleration acting in here?
Do neither of the other two want to have a go?
You're not
Any
talking to me,
ideas?
I hope.
Why not, Terry? Have a guess.
Paul, should I say the word centrifugal and centripetal at this point?
Yep.
Yep. That's what that's just trying to work out whether it's not towards the sun. It's either in a straight ahead motion or actually out, but I can't remember which it is.
No. Go with your really initial words there, farmers.
Yeah.
What? Not towards
Because
the sun.
you think you've got to change the direction. Instead of going in a straight line past the sun, you've got to change it so it ends up going around the sun. Which direction are you going to push that car from, Farmer's Boy, if it's a car going in a circle around a central pole? Which direction do you have to push the car in? From which side do you have to push the car to make it turn towards the centre?
You just can't see that, can you, is what I'm drawing.
Yes.
We can.
You just drew yellow out. There you go. Now it's purple.
Yeah,
That's
no,
purple, is
purple.
it? Ah.
So if I've got something driving past a peg in the ground and I want to make it go around that peg in the ground, which way do I have to push on that object to make it turn
you're pushing
towards
it
that
ahead.
peg? You've got to push it literally towards the peg. Okay? So if it's a car, you've got to push it on the outside towards the inside to get it to turn towards the peg. And you've got to constantly keep on pushing it towards the centre of that motion to keep it turning towards that centre. Does that make sense? I hope so.
Space Hammer Man.
Yeah. Well, think about, like whirling a rock on a string around your head. The only reason that rock goes around you is because you've got a rope pulling it towards you. Right? That rope, the tension acting on that rope is clearly towards you, towards the centre of that motion. Okay? And it's going in a circle around you. So think of gravity acting like a string between the sun and the earth, pulling on the sun, pulling on the earth towards the sun. There's a tension in that string, and that's what the gravity's doing. So the actual force is acting towards, the acceleration therefore is acting towards the centre of the circle. And that's one constant feature of circular motion, is that the acceleration is always towards the centre of the motion. No matter what other forces are acting, the net force must always be towards the centre of that motion. Here's probably the hardest part of it. So, knowing that the radius of the Earth's orbit is that, can you calculate the mass of the Sun, given that the gravitational constant is 6.67 times 10 to the minus 11 metres squared per kilogram squared?
Oh, Paul, you know you got the value of G wrong. Apparently Blue says the value of G is 6.63.
Oh, okay.
And he says he should bloody well know.
He knows, he's measured it, yeah.
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 I won't repeat the exact words.
Yeah. Any idea how you'd go about this? Did you manage to get this one, Alan?
We did, yes.
Yeah. How did you do it?
You know the diameter,
Yeah.
so you can work out the circumference.
Yep.
you know how long it takes to go round.
Yeah.
You know the period, which is about 31.5 megaseconds.
Yeah.
So you can work out the tangential speed.
Yep.
Oh, bugger, I'm trying to remember how we. And oh yeah, which then gives you the centrifugal acceleration.
Hmm.
So you know how fast it's accelerating towards the sun.
Yep.
And then you use the acceleration equals big GM over R squared.
Yep. Yeah. And what did you end up coming up with?
I can't remember. The trouble is, I made some notes on a piece of paper, and I kept writing stuff down, and I've forgotten which one of the. And there's some phone numbers and stuff on the page as well.
Oh, okay.
Number
we
is
won't
the
get you
answer.
to read it. We won't get you to read out any of the phone numbers. We don't want you to dox anyone. Oh, dear.
Yeah, the only person I'd be doxing would be myself.
Yeah, but your method is pretty much right there. So here I've got the calculations, all right? So the force on the Earth from the Sun is given by Newton's law of gravitation, F equals G_m_m on R squared. And the force needed to keep the Earth in circular motion is given by F equals mv squared on R. That's the centripetal motion, all right? Equating these two, we have that G_m_m on R squared equals mv squared on R. They're the two forces equated to each other. And you can rearrange that to get big M, the mass of the Sun, after a few things cancel out and stuff, and you transfer the other things over to the other side, you get it's equal to V squared R on G, big G, all right?
Yeah.
But you can know that the V is calculated by the circumference, which is 2 pi R, right?
Yeah.
Yep. And you divide that by the period, which is T, all right? So when you square that, you get 4 pi squared R squared on T squared, and you put that into the equation, and you rearrange it all, and you get the big M equals 4 pi squared R cubed on T squared G. All right? Not a simple thing, but if you put all the numbers in there, which I've shown you there, you end up getting a mass for the Sun of 2.0 times 10 to the power of 30 kilograms.
That is what Blue and myself got.
Excellent. Well done. Yeah.
I
think the actual figure is something like 1.99 times 10 to the power of 30, which is pretty good. Yeah.
We did have to collaborate on that though a little bit.
Okay, yeah. I'd probably say this was the hardest question in this whole lot here. So, but by knowing centripetal force and by knowing the Newton's law of gravitation and equating the two, you can rearrange them and calculate things like this. And, you know, flat earthers wonder, how do we know the mass of the Sun? Well, this is how we know the mass of the Sun. Because we know the period of motion of things that are orbiting around the Sun. And how do we know that? Because we've friggin' observed them and looked at it, and we can measure the period of motion around the Sun of these objects. Do we have to know the mass of the thing going around? No. All we have to know is its distance and its period of motion, and we can calculate the mass of the central body.
Yeah, that's what me and Terry got all this as well, didn't we, Terry? We got this as well.
We've been doing them and each other.
Yeah, you've just been holding back.
Yeah.
Yeah.
My personal biggest problem is I do struggle somewhat with maths and with rearranging the equation. Yeah, with remembering the right equations and then rearranging them to be how we want them to be.
Yeah.
Well, welcome to my world, but 10 times worse than that, Alan. All right.
Now, I can't see the first part of this question, but I do remember it. It's something like a package, a box with a mass of, I think it's 30 kilograms.
30 kilograms.
Is loaded onto a, yeah, 30
slide.
kilograms. Is slided onto a slide from the second floor and slides from rest to
the ground floor below.
Yeah, below, as shown in Figure 4. So here
And-
is Figure
Yeah.
4.
Slide has a linear length of 6 meters.
Yep.
And a constant friction force of 50 newtons on the box.
Yep.
The box reaches the end of the slide with a speed of 8 meters per second.
Yep.
What is the
What
height
is the
between
height
the floors?
between the floors? Yeah.
Get your tape measure out.
Yeah. Did you have any idea of how to solve this one, Alan?
I didn't even start on this one, to be honest, Paul, because it got too close to the start of the show.
Okay.
And,
Yeah.
everybody
no
else showed up in the VC in Discord.
Yeah. Any idea about the physics that might be involved in this one? How might you calculate the height of this, or what sort of principles of physics might you use in this?
Well, I'm going to resolve everything into horizontal and vertical components for a start.
Mm-hmm.
Or at least I'd like to.
I'll give you a hint. This question's more about energy than it is about resolving velocities and motions and stuff.
Okay.
Okay.
In that case,
So-
it's time for Alan to have a lesson.
Okay. Yeah.
Or at least to remind
this
the
is
lesson.
more. Yeah, this is more of a question about work being done and different forms of energy. Okay, so as the box slides down the ramp, work is being done. Okay, and the amount of work being done. Can you remember what the formula for work being done is in physics? Anyone know? Any of the peanuts know out there what
I think
work is in physics?
I think Dora's got it, because look at her answer for number 14.
All right, so what has she got? She's got potential energy equals kinetic energy plus loss due to friction. 30 times 9.81 times h equals okay. Okay. So, yes, I would agree with that. So here, the work being done, I haven't answered this question correctly. I can tell you that right here and now. Dora has done a much better job of it. I've ignored one part, which was the kinetic energy of the thing afterwards, but she's absolutely correct here that you have to do the kinetic energy at the end is half mv squared, which is half times 30, which is 15 times 8 squared. And you then need to know the amount of work being done is the force times the distance. The force being 50 newtons times 6. So you would do the 50 times 6, which is 300. The half mv squared, 15 times 64. Don't know what that is. I'm going to defer to Dora here. So she's got, let's have a look there. We've got 30 times 9. She's used 9.81. I would have used 10, but it doesn't matter. I would say Dora is correct in that answer. I know I've got the wrong answer here because I ignored the kinetic energy at the end, which is wrong. Bad boy.
No, you didn't ignore it. You forgot it.
Yeah, I forgot it. So yeah. So the correct answer, I will say, is Dora's answer. Well done. Yeah.
I think you want to flick that back one at the minute, Paul, so we can actually look at the answer.
But that's not the answer. That's the reason why I flipped past it, because I didn't put in the correct parts there. I'm going to say that Dora's answer is the correct answer there, Alan, because I ignored part of it there, which was the kinetic energy at the end. Okay. So essentially what you've got to do there is you've got to think that the potential energy, it's got a potential energy of mgh, all right? So the mass, which is 30 kilograms, times g, which if you assume is 10, makes it easy to calculate, right? So 10 times 30 is 300, then times the h, whatever the height is, okay? And that must equal the sum of the other energies, okay? So you lose 50 times 6, which is 300 joules, in the work done in sliding down the ramp, because work equals force times distance, right? You then have a remainder of half mv squared in kinetic energy at the bottom, which is, so you have to have the half mv squared, which is half times 30 times 8 squared, which equals what? So 15 times 64, whatever that is. That'd be 64, 32 is 94, 96, 960. And then half of that, 450, 480, and then 480 plus the 300. 580, 780. So 780 must equal mgh. So divide the 780 by 10, which gives you 78, divided by 3. Whatever 78 divided by 3 is. That'd be 20. No, that's not right. Look, I'll just defer to Dora about having the correct answer there. Anyway.
Fair enough.
Yeah. Yeah. Anyway, okay.
36.
Wouldn't be 36 meters. That's a big distance to have between floors.
Anyway,
yeah, I'll work it out and get back to you on that one anyway. Yeah. So this time there's a spring at the end and it compresses. All right. The spring has a force constant or a stiffness of 30,000 newtons per meter. How far will the spring be compressed when the box comes to rest? So you've got to think about this. So Dora says 960 plus 300 equals 300 times h, therefore h is 4.2. Yeah, that seems reasonable to me, Dora. All right. So here, what's happening? When the package slides down and it has a velocity of 8 meters per second horizontally there, it's going to hit the spring, which is going to compress and exert a force on the box and slow it down. So how far is it going to compress? How would you know how far it's going to compress? Well, you need to know how much energy is stored in that spring. Okay, so how much energy is stored in a spring? The force needed to compress a spring is given by this equation, F equals minus K delta X, where K is the stiffness of the spring and delta X is the amount that you stretch or compress the spring by. All right. And the kinetic energy of the package is going to be stored as potential energy in the compressed spring. How much potential energy does the compressed spring has? It has half K delta X squared. So we know that that's got to equal 30,000, all right? Because, so half mv squared equals half K delta X squared. And so when you can put numbers in that, you get 30, which is the mass, times 8 squared equals 30,000 times delta X squared, because you can drop the halves because they're on both sides. And when you rearrange that, you get a delta X of 0.25 meters. So it should compress by 1/4 of a meter, roughly. So that was pretty hard too. But it just means that when you compress a spring, you store energy in it. And that was some mechanics for you for today. There you go. Done.
Physics tests on a Saturday. There should be laws against that. I really should.
Yeah.
I've had hell of a week. I really won't in the mood.
Yeah.
Oh no! I like fluffy kittens.
Well, we could have a quiz about somebody giving you 5 ice creams, not ice creams, and then how many have you got left or something.
Well, I'll do a quiz like that next week, Terry. On Wednesday, I'll have an easy quiz for you.
I'll tell you how. If you give me 5 ice creams, I'll tell you how many ice creams I've got.
5.
None, because I've eaten a bloody lot, sod you.
Yeah.
Yeah.
I did buy some more ice creams today when I went shopping. Sorry, Alan, I got some milk. Had I known, I'd have got you some too.
Welcome, Space Matt.
G'day. How is everybody?
Oh, we're good. We're good.
Knackered.
We just brained our drain.
On that well, just
Drained our brain, sorry.
Drained your brain, yeah. I'm glad I come to the end of that.
Mine was already drained mate. I'm sorry.
Well, we did have Lindsay to start with, and then some review of even more.
Yeah, well, Lindsay will do that too.
I was to say, yeah, you needed to create some more brain cells, didn't you? To after that, connect some, make some new connections in your brain.
Yeah.
After
Did you know,
destroying
Matt,
a few.
that Antarctica?
No, I didn't know. I didn't know.
You didn't? Did you know that Antarctica is just off the coast of the Australian mainland?
All right, okay. Just off the coast. Like how far? Just off the coast?
A few miles.
Yeah, a couple.
A few miles. All right. Who said that then?
It's that bit of video when they're out in the fishing boat as old load on. They reckon they're going to Antarctica, and the Australian Navy turn up and turn them aside.
All right.
It turns out they're in the Bass Strait, in between
Who said
mainland
that?
Australia and Tasmania.
Well, there's a new.
Who said that? Was that Lindsay who said that?
No,
No,
new
that
movie. It's out.
Well, actually, that clip's been
that
around
one.
for a while, and I think Arctic Reflections covered it in his latest video.
Oh, is that the big flat Earth video by what do you call him?
Yeah, that one.
That one. Yeah.
That one. Yeah, that one.
I can't remember what it's called. Yeah.
But that's been in. I saw that a few months ago. That's been circulated a few times. But they're saying, we were stopped on the way to Antarctica, and they're guys who are obviously dressed for a really quite a nice day. You know, let's just let him. And they're obviously on a little fishing vessel. And there's an Australian naval vessel, whether it's a destroyer or whatever, I don't know. But they're basically saying, no, you're not allowed to go here because they've just strayed into a naval exercise area where they're probably using live munitions.
Oh, right. So they're seeing that. Oh, yeah, they're protecting Antarctica
And
when
they're
they're
pretending
several
they're on the
thousand
way
miles away.
Yeah, and they're actually in between mainland and Tasmania.
And the bit at the end that really made me laugh was the fact that they can't even give the latitude and longitude correctly.
Well, no, of course not.
They got the latitude without the correct sign.
Yeah.
Yeah. Well, they would, wouldn't they?
Yeah.
Got a lie to flirt, as the saying goes.
Helps if you're an idiot as well.
Yeah, helps you an idiot too. Yeah.
That's pretty much a prerequisite. You got to be an idiot and a liar. Welcome to Flat Earth. Yeah.
I still, it amazes me that they're still saying, even now, that the Antarctic Treaty means that you can't go there. Well, you know, and it's been challenged so many times. We'll point to where it says that, and it doesn't. I've read it. I've looked at it several times. It doesn't say. It doesn't even imply it either.
It's only
But they
something
still
like a
use
dozen
it.
pages, isn't it? It doesn't take long to read through it.
No, we did once. I remember.
Yeah.
I was on Geo's server, right, and they were talking about Antarctica, and it came to pass that they came to know that I'd actually been there twice, right? And they were asking me about it, and they were asking me all sorts of questions to try and trip me up and figure out. And they said, were there security guards there? And I said, well, yeah, there are security guards there, you know, for your own safety and to provide security around the installation, because like any place, you've got people. There are bound to be some people that do the wrong thing, so you do need security. And then the next question they asked me was like, well, what kind of guns did your controllers have? Man, they just totally reworded it and twisted it around.
That's how it works.
Yeah.
We have a naked TT guy on the panel.
Oh yes, we do.
Yeah. Just don't.
Shouldn't have
Nobody
let him
look.
in.
Don't look at the naked TT guy.
Oh dear, I've hurt my eyes.
They just, but they did. They watch all this nonsense being spewed on YouTube videos, and they just, you know, blindly accept it as the truth because it goes along with their own level of derp. And none of them seem to think, well, hang on, is this actually the case? Because obviously flat earthers don't do research.
Yeah.
No,
And they
that's
asked me,
an-
like,
that's
did
an
you see
word.
the 24-hour sun? And I said, yes. And they said, so that means you stayed outside and watched the sun for 24 hours.
24 hours.
Yeah. I think I think deep down most of these know.
Yeah.
I think they know what the truth is, but they just they want to play silly buggers and just be part of this little group where they're all welcome and they're all, you know, equally as intelligent as each other.
Well, you could film the 24-hour sun in real time, for.
Oh
Well,
yeah,
if they won't believe one, like Alan says, if they won't believe one picture of Antarctica, why would they believe 3 million pictures served to you at 30 pictures per second?
Exactly. It's already been. Oh, why don't you film a 24-hour sun? People have, and you just dismiss it and you say, "Oh, that's not real."
Exactly. Yeah.
And that's, I don't know why people start jumping through hoops for these idiots. Well, show me this, show me that. What's the point? You'll just deny it. You'll just go, well, that's not real. That's CGI. That's fake.
Yeah.
2.6 million photos in a day.
Yeah.
Show me photos from space. Yeah, we have, but they're not real. Well,
show me, yeah. What's the difference between one photo and 2.6 million?
Yeah. I've been having a bit of a to and fro with Carl Adams on Facebook. He's actually, yeah. He was talking about, what was he talking about? The classic one, the wet flag. You know, the Apollo 17 flag.
Yeah.
Apparently that is wet. Apparently, you know, that old one the Globebusters did. I don't know, years back.
I thought he's put to bed ages ago.
Yeah, I thought that was as well. But Carl Adams, being slow as he is, he's apparently he never knew anything about it until just recently. And Globebusters did that 3 years ago, something like that, 2 years ago. Yeah,
This photo with Harrison Smith and.
No, it's not. Yeah, well, I think I'm not 100% sure, but anyway, it's irrelevant anyway because they're concentrating on the flag. They're saying it's wet. Well, the thing is about, some of you might know, is that particular flag is made of nylon, and that particular flag also is a bit bigger than the rest of them because it was hanging up in the Mission Control Center in Houston, and they decided to use that one for the very last mission. And then what I showed them was the information page about that particular flag, and before it actually went to the moon, the assembly of the flag, the pole and all the rest of it. And there it is sitting in the studio lights with the same sort of effect of that nylon thing when you got the dark patches and light patches, as nylon does, because it's a plastic type of material, isn't it? You know, but Carl wouldn't accept it. He says it looks different. I said, really?
No, because he wants it to.
Because he wants it to.
It's no point presenting them with evidence, because if it doesn't fit with their deluded belief, they just reject it out of hand.
The way he presented, because he made a video about it, and the way he presented it was that really all he's doing is his opinion that it's wet. He's got no proof that it's wet. He's got no evidence, only that it looks wet. And I was trying to point that out to him, but no, he says that's evidence. I said, that's not evidence.
No,
it's not evidence at all. It's just your opinion that it looks wet. That's all it is.
They're made out of nylon, aren't they?
Yes.
Well, I'm not sure. Were all of them made of nylon? I'm not 100% sure.
I thought they were all made out of nylon.
Yeah, because obviously nylon's nice and lightweight, but it also has that slightly shimmery look in the right light conditions.
Yeah.
And I don't know, no atmosphere probably will give that. You know, you'll probably get that sheen you associate with something being wet.
Yeah, you will. Yeah.
And they had lots of creases because they'd been rolled up and put away for quite some time. So when they got them out, you know, it's not like it's not like you just unrolled it and there were no creases. Or it's not like, unroll that all quick, just put an iron over it.
That's right. Yeah. No.
Yeah, so you get all these creases and things, and of course it's in bright sunlight. because that's what you get on the moon. If it's lit up, then it's going to be bright sunlight because that's all you're going to get. And it's only going to accentuate any sort of shading, shadows, or light sort of coming off it in a certain way to make it look like it's wet because it's shiny material.
Yeah, because oddly in space, or certainly on the moon, you're going to get sunny 16 pretty much all of the time.
Yep. And the other part of his video as well, which I pointed out again, he's making an assumption, which he did with the flag, was that there was white kind of streaks. Now, I didn't comment, but he basically told me that, are you saying those white streaks on the Apollo 17 spacecraft on the window is not water? And I said, well, hang on, that's a nice straw man, because I never even commented on it. But you're assuming that I'm telling you that it isn't water. I don't know what it is. But he's making an assumption again. He's saying that it is water that's on the outside of the spacecraft. But I need to look into that. I don't know what it is. But again, it's opinion. He thinks it's water. That's all it is. But he seems to think that it's fact. That's evidence. And in fact, his last comment to me was, we've obviously got a very different opinion as to what evidence is. And I said, well, you haven't presented any evidence. You just presented opinion and assumptions.
I bet you he couldn't even give you a frame number. I bet you he couldn't even give you the bloody cartridge, the cassette number.
Oh, he did. No, he did. Yeah, it's on. He presented it there. Yeah, he did. Give him that much. Yeah.
You did actually give the player 17 dash.
Yeah, you did. Yeah.
148.
Yeah. Yeah, he showed he got that directly from the NASA website, as he has to do, as if it proves something. So yeah, he did that at least. Yeah, so it was AS17 whatever. I don't know what the rest of the number is. Yeah, so at least
I know somewhere to go now to find a really good copy of all of those images, although they are a bit dark.
I don't know. I might do a little bit of a video on that interaction. I think it's kind of interesting to me, at least. Anyway, maybe not tell other people. I don't know.
I can understand why they do scan them so dark, it's just so they don't lose any of the highlights.
Yeah.
I mean, it's strange. I'm looking at that photo now on NASA's Flickr album. I'm actually looking at the photo of that flag.
Yeah.
And there's nowhere on there where it looks wet.
Oh.
It's full of creases. It's got bright bits and it's got bits in shadow, and I can't see anywhere where you'd say, "Oh, look, that looks wet." It's just.
So what I plan to do is I would plan to find on the internet lots of other materials that have got made of that same material and say them to them, look, it looks the same. This is what you kind of effect you get with nylon because it's plastic material. So yeah, I thought I might make a nice, interesting video.
I'm trying to find where the photos are that show white streaks on the windows, but
yeah, I haven't really looked into that properly yet. As I said, I didn't comment on it because I didn't know what it was. But I'd like to do some research into that. I need to figure out where he got the image from, whether it was Apollo 17. I'm only guessing it was. And there's white streaks apparently on the window. I have no idea what it is. No idea. And I didn't give any opinions to what it was. But he seemed to
that he thinks it's white streaks because didn't they have marks on the insides of the windows to help them landing?
No, it's kind of like it does look. I must admit, it does appear as if you've got some sort of liquid that's been heated, and like with you sometimes get the streaks on windows, and it's left as a residue, like the chalky sort of residue.
Yeah,
if it's been like it's been superheated, so there could have been a liquid on the outside during re-entry of some sort. I don't know. Who knows? Don't know. I haven't got a clue. I'm only guessing. But it did kind of give that appearance.
Is this a command module or the lunar module?
Command module.
Right.
Molly asks Kyle if he was figured out how the SS is falling for 20 years, but it's still going the same speed, Matt.
Oh,
yeah, he put that on. He put that on Facebook as well. Yeah, that one. centripetal force is to do with them.
But like I said, he came into Mr. Sensible's and asked us, and people gave him the same answer, and then he just obviously ignored that and made that video anyway. Because he said, "Oh, how come blah blah blah," and everybody told him, and that was just no, thank you. I'm going to ignore that. That's not what I want to hear.
I managed to. It took me quite a while. I managed to actually tie him down, and I said, "Are you actually commit to an answer? Are you actually saying that centripetal force is not the force that's actually stopping it from constantly accelerating?" And at first he wouldn't get it, but I had to get it, squeeze it out, and eventually he says, "Yes, okay, that's what I'm actually saying." So yeah, it was very telling that at first he wasn't prepared to commit to a proper answer or not.
Sure.
Because some won't, and they're the ones are not flat earthers. Oh, wonderful people.
Oh, speaking of space.
An update from James Webb's really interesting on this one. Actually,
not
it's really
quite.
good.
It's probably a bit of both, actually. Hopefully, but does anyone know what a Herschel observatory is?
No, I don't.
You've forgotten all about it, have
Herschel.
you? Herschel observatory. Don't know. Neither did I.
Isn't that another one that we've got in space? As you know,
well, we'll find out about it.
The Hubble and the Herschel. Isn't that
No, I've finally managed to get the famous Apollo 17 flag picture up that I was about to share, but never mind.
No, you can share.
Oh, next time, Alan.
You can share it if you've got it there ready to go.
It took a while to
share
to load because it's a PNG of the what's happened?
You shared the wrong window.
Yeah, got the wrong window. That's your banana. Sharing your banana.
Okay, let's stop sharing. Let's stop sharing.
Yeah, stop sharing it. Because you're showing your banana.
You don't want to do that.
Who are Mrs.
What the hell is that called?
Where'd you open it up in? Just in.
I opened it up in photos.
Well, you drag it across and put it into Google, into your Google window, and that'll open it up in there.
Yeah, I wanted to. Yeah, no, that's not going to work, is it? For some reason, it won't.
Then you can share your Google
window. It won't even let me shut the screen now.
Oh no, you broke it.
No, I broke it. Yeah, I mean, I can drag it into. What the hell?
You guys have been having a lot of tech problems recently, haven't you?
No, well, only because I tried to play some sound through somewhere and it mucked up all my settings, so I had to.
Yeah, I was listening to some of it yesterday.
I won't do that again in a hurry.
I found a photo that he could possibly be talking about, but that's from Apollo 12, and that is actually fogging that occurred in between the layers of the windows.
Yeah, this looked more like streaks.
Hang on, I'll copy that and I'll post it in Discord. And thank you, Bobs, by the way.
It's probably give me the right window.
Chuck it in. I don't know, Fair Suck or something, I suppose.
Oh, yeah, hang on, it's too big.
Oh, yeah.
That's what she didn't say that.
Do a screen print of it or something, and that usually works for me.
Yeah, I'll do a screen grab. This whole it's bigger than 8 meg, yeah, and
yeah.
I have. What am I sharing?
I got no idea, Alan.
Well, if you don't know, we don't know.
Yeah, that's the one, Alan. I'm pretty sure that's the one.
There you go. I just stuck it in Fair Suck.
That's
just one I found.
Yeah, so the bit, if you zoom into where the blue part, particularly the lit up blue part of the flag, that's the bit they were mostly concerned about.
Oh, I can see a big blue dot.
Even a bit more if you're able.
Yeah. It's the part of the problem is that then you get in here and it doesn't want to zoom very well, does it?
No, it doesn't. I know. I'm not 100% sure whether it was even that image because they had all the rest of it cropped out, of course.
Of course.
So it might not be the same one. In fact, it probably isn't quite the same image. But it's of the same flag and it's of the same mission anyway.
I mean, this is the famous photograph of the flag on the 17 mission.
Yeah. So if you see where you've got the two on the bottom left quadrant of the blue part, where you've got the stars, see the two left-hand stars, the bottom left-hand corner. So it was that patch they were mostly concerned about. You see, it's darker, so therefore it's wet.
Even though it's the sun's shadow, the shadow of the flag.
Yeah. Yeah.
That's obviously got some shadow on it.
But with nylon, if you crinkle nylon, even more so, it's not even so much that it's the shadow; it's the way that the material was actually formed. Kind of gives you these dark and light patches. It's not even shadow. That's the thing about pure nylon.
Because the thing is also when you get the direction of the weave.
Yeah.
Sometimes it reflects. The weave reflects light differently depending on the angle the illumination's coming from.
Exactly.
Materials are.
Yeah, exactly. It's just that they don't seem to understand how a nylon works or what even nylon actually is. They just think it's something like cotton, and the cotton just doesn't behave the same way.
But cotton does the same thing if you get it in the right light. It's just.
Oh, does it? Maybe not to the same degree. Anything
that is woven, because you've got the weft and the waft and all that stuff that weavers do. If you change the direction the light's falling on, the weave, it will change the apparent brightness. It can even change the hue as well sometimes.
Yeah. But what I suggest, maybe not to the same extent, because I don't think cotton's quite as reflective as nylon, is it? Would I be right in saying that?
Probably. Yeah, the reflectance of the material will make a big difference as well. And of course, nylon tends to be more reflective. You can see it in the red stripes on the left here as well, can't you?
Yeah.
There are areas that are being directly lit and areas that are in a slight. It's not total shadow, but it's. There's a degree of shadow for
yeah.
And it's what you flipping will expect when you've got creases and stuff in it.
And actually, there was another guy that pointed something out, which I think is relevant as well. If a material was wet, see those stars. You see those stars are embroidered, right? Now, if the flag was wet, you would expect it to dry out. The last part of that flag would dry out around those embroidered stars, right? Because it's thicker.
Yeah.
You'd expect that, wouldn't you?
All the
so I think
all the stitched areas would be darker because they'd be the last
bit
to be wet.
The last bit to dry out. Yeah, absolutely. Yeah. That's what you'd expect to see, but we're not seeing that in this flag, and so therefore, I don't know how they can draw the conclusion that it's wet. But of course, it was just kind of like, it looks wet, therefore it is. No, that's how they work. Because they want.
I can remember having this conversation before about flags as well, somewhere.
Oh, we have a few times, yeah.
This actual image was something that we discussed about, something to do with the image and the reflection in the helmet.
Yeah, we did, yeah.
We did it on one of my live streams, I believe.
The TT guy, we can't. I can hear you. I can see you talking, but we can't hear you.
You finished with that? You can stop sharing.
Yeah. Hang on. There we go.
There we go. TT guy.
Yeah, TT guy.
He's fixed up.
Guy, I can see him.
He's not naked anymore. Well, that's.
You're muted, TT guy.
And when I'm not muted, can you hear me?
Oh, that's better. Yeah, I can hear you now.
Oh, yeah. Okay.
No,
I was going to say, doesn't the next frame in the flag image, doesn't the wet spot move? Different spot on the flag?
Can't remember. I can't
Sure.
remember.
Because they
I
only
don't
do the
think-
analysis on that one frame, and then if you actually play it, oh look, the wet spot moves. So I think it might be just a reflection on the nylon. Yes.
Interesting point. Yeah, it's a good point actually. That good point. I'll use that in the video. Yeah.
I expect credit. Yeah.
Yeah,
you
got to give him credit.
Because he took.
I will.
He took that frame by accident. The one where you can see Harrison Smith with the flag and the earth in the background. That was a complete and utter fluke. That photo.
Oh yeah.
It was falling over when he took it.
Yeah. Yeah. Brady. Yeah, it was a difficult shot from the tape, wasn't it? It took a few attempts. No, a couple of them were rubbish.
Matt, I'll tell you what I saw in an auction on eBay yesterday.
All right.
A really nice looking Hasselblad 500 ELM.
Oh, really? That would be nice to have, wouldn't it?
Yeah, I mean, not with the right lenses, but I mean, it was a nice looking ELM 500 with the eyepiece viewfinder.
Oh, nice. How much did that go for in the end?
Well, I don't know because it's still got four a bit. It's in Georgia in America as well, so it's like getting it here was going to be another £100.
Mm-hmm.
Yeah, beyond our price range, that's for sure.
That'll probably sell for about £1,500.
Yeah.
If it goes to about the values they go for.
Yeah, sadly, I haven't got £1,500 to spare.
No.
But it'd be something more nice for you to have, being a photographer, than me.
Just to shove it down somebody's throat.
Yeah.
Oops.
Yeah.
Did the aliens just take Paul? Did he? Did they?
I guess so. Yeah, he just dropped.
He said he may have had trouble with his internet, but he wasn't sure if he was. He may be back. He may be back.
He is allegedly still in Discord, but
he's still in Discord.
Oh no, he's not. He's just dropped from that as well.
Oh no.
I'm going to say, Discord's good at keeping you in there when you've actually lost.
He just dropped out of there, so I suspect he's just lost his interwebs.
Okay, TT guy, you might not have heard the question. Do you know what the Herschel Observatory is?
Negative. I imagine you use it to observe things.
Well, yeah. Well, I didn't know about it either
things in the sky.
until I had a bit of a preview of this video and I had a look into the Wikipedia page of it and everything, and I thought, oh yeah. Okay, so we'll watch.
I'm going to guess it's operated by the Brits because Herschel was actually a Brit, despite his not very English sounding name.
I'll have to bring up the the Wikipedia thing for that to read into that, but we'll just watch Anton's information about it. I've got it already here. And then we should have a Simon somewhere, or a Everett Anderson, or someone. There's a flat earther debunked by his own car, CC Chris. I forget who did that one. I think that might have been Mr. Sensible.
Oh, that was I think Mr. Sensible, that one.
Sounds like a Mr. Sensible thing.
I wouldn't have mind just to CC's actual video for that one. That probably would have been better for us just to have watched his raw video. I'd have to go and find that. You mean I'd have to plan something?
Yeah.
Oh, sorry. Hello. What's a 4-letter P word, TT?
A 4-letter what word?
A 4-letter P word.
The word you say before off?
It could be, actually. No, it could be. It could be.
Yeah, it could be. Many people do.
And no, it's not.
I would think it would be a word that comes after an indicative. Usually go.
Do you want me to say it, Terry?
What?
Press play.
Have you never heard of playoffs?
Yeah, playoff. Yeah,
Exactly.
Playoff.
yeah. That's what TT
It wasn't
meant.
piss
I
off,
think.
it was playoff.
Yeah. Or piss
Oh,
off. Yeah.
precisely. Yep.
Yeah.
I've got no idea, but now I do. Okay.
Yeah.
Yeah.
Play.
Look at that.
Nice.
And who remembers my thumbnail for the video?
Herschel.
Ah,
There was one telescope, and that kind of made me realize the power of social media and the power of hype of the internet. Hello, wonderful person. This is Anton, and today we're going to be talking about that other telescope we seem to have forgotten about. And I mean really forgotten about. Okay, so let me give you an example. So just based on this one simple video, I think a lot of you will probably be able to name the telescope. That's of course the James Webb. Okay, how about this one? Well, I'm sure a lot of you can name this one. Many of you even have a Lego version of this. This is the Hubble telescope. Both obviously pretty famous, and mostly famous because of the representation in the media and all of the images they were able to create over the years. What are we looking at
And Spitzer,
right here?
of course.
What is this called? Where is this from?
well,
Who made this?
If you
Does this
remember my
exist?
thumbnail,
Did
yeah.
it exist? And so yeah, that's the telescope that was actually right between those two other telescopes, between
Herschel,
the
yeah.
Spitzer and the James Webb. The infrared telescope with a mirror approximately 3.5 meters across. A little bit smaller than the James Webb telescope, but way larger than Spitzer or WISE. And though I'm sure some of you are screaming at me right now saying, of course we know what this is, and naming it out loud, in reality I think a lot of people completely forgot about the Herschel Space Observatory. The observatory that operated between 2009 and 2013, the telescope that was also extremely large in size and was actually launched using exactly the same rocket as the James Webb telescope. And moreover, it was launched into the exactly same orbit using exactly same profile. And so if you ever wondered why ESA was able to launch James Webb telescope with so much precision and create such an opportunity for the mission to go on for 20 years, it's because they've done it before. They've done it using Herschel Observatory. And so because this particular telescope wasn't really discussed much in the last year or so, and because it actually played a huge role in the successes of the James Webb telescope, I wanted to briefly discuss what this was and what it discovered in its 4 years of operation. But also why it's no longer operational and what the scientists learned about the operation of infrared telescopes since its launch. So first of all, this was not a NASA's mission. This was a European Space Agency mission. And it was also a mission launched during the time when the space missions in general were slowly becoming less and less popular and were generally not talked about as much as they're talked about today. And I would even go as far as to say that it was actually because of SpaceX and because of their successes and various failures that were documented over many different videos that made space cool again and made people interested in various space missions, including various telescopes. And NASA realized that and joined on the opportunity of using a lot of social media and a lot of, I guess, hype in a sense, to try to make us all excited about various Mars missions and of course about the James Webb telescope as well. But Herschel was launched in 2009, and it was launched to very little fanfare, but the mission profile in this case was almost identical to the James Webb telescope. It was to be launched into the Lagrange 2 point, located behind planet Earth. It would then orbit the point of nothingness for several years, and it would try to stabilize its orbit using limited fuel. But unlike James Webb Telescope, whose operation is essentially limited by the amount of fuel to maintain this particular orbit, for Herschel the limit was slightly different. It was because of the coolant used. Just like James Webb, it used an active coolant. And in this case, it relied on liquid helium, which would cool down the device for approximately 4 years. And once the liquid helium ran out, that's when the mission would be over. But the thing is, the James Webb Telescope also uses a relatively similar cooling technique, especially for this instrument right here known as MIRI. It has to be kept at approximately 7 Kelvin. That's super cold. Here's what a typical cryocooler sort of looks like, and this is from James Webb Telescope and is somewhat similar to the one on Herschel as well. But unlike Herschel Observatory, this one also has something else to cool it down. The enormous sun shield that you see right here that does most of the cooling on the telescope, with the liquid helium only required for even further cooling, which in theory makes the cooling system on James Webb
Telescope just shine moonlight on it.
Way more efficient
and
allows it to
cold
operate
moonlight,
for an extremely long period of time, in theory actually indefinitely. But Herschel Space Observatory did not have that, and so by 2013 it essentially ran out. Although up until that point, this was the largest infrared telescope ever built, up until 2021. And what I find really intriguing is that this mission was also approximately 10 times cheaper overall, way more efficient, even though overall it was just as complex, involving just as many years of development and just as much commitment from various organizations as with the James Webb. The total cost of this mission was approximately 1.1 billion euros. And that of course includes the spacecraft, it also includes the mission expenses, and all of the scientific operation for roughly around 4 years. And just like the James Webb, Herschel specialized in collecting the data from the Milky Way galaxy from various extragalactic objects billions of light years away from various newborn galaxies, and overall it made over 35,000 scientific observations and was involved in over 600 different observation programs, many of them available right here in Herschel Science Archive, and nearly 3,000 different publications mentioning the data from Herschel at some point. And pretty much every single image involving distant universe in the last few years involved the data from Herschel. Here's for example one of the previous discoveries of 2 galaxies colliding really far away. These were the images produced by this telescope, and that's essentially what the scientists had at their disposal for many years. But the thing is, many scientists have gotten so used to this data that in many different publications the name Herschel Observatory is not even mentioned. And that's basically to show that it became so established in astronomy that many papers would only just mention far infrared data. That would always mean Herschel Observatory. But in the last decade it also made quite a lot of different discoveries based on all of the data collected. For example, discoveries in regards to very unusual steps in various star-forming processes, some processes previously unknown to us, such as the discoveries from NGC 1999, this unusual dark nebula that seems to discard material around the system in a way that was previously unknown and never seen before. It was also the first telescope to officially confirm the existence of oxygen in various regions of the galaxy, the existence of water vapor around various star systems, and to be more exact, the detection of a lot of cold water vapor around very young stars forming accretion disks, which then of course led the scientists to the discovery of how the water most likely ended up on our planet. And it also discovered several unusual and quite exceptional starburst galaxies, such as for example HFLS 3, the galaxy you see right here, that was located billions and billions of light years away from us when the universe was only approximately 880 million years old. And this was one of the strangest starburst galaxies ever found. It was also the first telescope to officially discover huge numbers of so-called interstellar filaments that are now believed to be a crucial step in the birth of various stars, and even was the first to confirm the existence of water on the dwarf planet Ceres, something that was assumed but never proven, with lots and lots of other incredible images produced over the years. And honestly, it's one of the most prolific observatories of European Space Agency. And even today there's at least one paper that comes out somewhere on the internet that mentions the data from this telescope in some capacity. Yet, almost no one talked about this in the last year, especially prior to James Webb launch. And honestly, I can only speculate why. I guess first of all, it's because this was launched prior to the advent of social media becoming a widespread phenomenon. When it was launched, Facebook, Twitter, and YouTube were still growing, they were still not as large as they are today. And of course, iPhone has just come out a couple of years prior, with a lot of Android phones still not really being that popular, and the idea of sharing media on social media not really being a huge phenomenon yet. Which meant that all of these incredible pictures were mostly used by astronomers and by scientific publications. Or at least that's what I'm guessing. I mean, there could be other reasons why it wasn't as popular, but in reality I guess we'll never really know. But in 2022, astronomy is cool.
Well, if it was more recent, the Flurfers would have latched onto it, and then we would have known about it, because they would have actually.
Yeah, that's true.
They would have gone straight for it.
Again, and so are various telescopes. And so in the last 10 years, things have definitely changed. But that's also why I actually wanted to mention this telescope, because it was quite productive. It was definitely one of the most powerful observatories of its time. But more importantly, a lot of the advances and a lot of the success of James Webb Telescope are directly related to the successes of Herschel. Like I mentioned, a lot of scientists that worked on Herschel are now working here, so we wouldn't really have this without that other one. And by the way, the name Herschel comes from the William Herschel, and also I guess his sister Caroline Herschel, both of whom were responsible for discovering both the infrared spectrum and planet Uranus. So definitely worth remembering the legacy of this incredible telescope. And, as I mentioned, all of the data that it collected over the years is available right here in the description below. On that note, well, that's pretty much it. So, right here, right between these two telescopes, you could technically put Herschel, with the actual data most likely being somewhere in between the quality of Spitzer and the quality of James Webb. I guess now all we can do is wait for more incredible imagery from the James Webb Telescope and to hear about its first discoveries and its first studies, which I've discussed in one of the previous videos, somewhere right there or in a description. On that note, thank you for watching, subscribe, maybe share this with someone who loves learning about space and sciences, and maybe come back tomorrow to learn something else. Support the channel on Patreon by joining a channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye-bye.
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 Oh, we'll have to get some updated images in the next couple of weeks to sort that one out, because we're not going to do every show about the James Webb, because it's.
Yeah, I mean, don't forget. I mean, these are preliminary sort of testing images just to sort of see how it's going more than anything else at the moment. By the time we get any science out of it, and start getting reports of it, it's going to be past the summertime.
Yeah.
We don't need a corrective lens put on it, so that's good.
Don't have to go.
Well, even if it needed one, they ain't going to get one, is it? So,
nope. But
don't need to go to Specsavers.
So, you know how the Fleurs don't live in space, and they'd be sort of saying that all that's fake. Can I get a job as the guy that feeds all the scientists the fake data? Because that wouldn't that be a wonderful job to go to work every day to fool a bunch of scientists feeding the fake data?
You could class yourself as a proper bullshit artist then, couldn't you?
Yeah.
Paid bullshit artist. That'd be class. Just make a load of bullshit up, send it to them.
That's what you see all that data that scientists guy had, all this sort of data coming, terabytes of data from these spacecraft. According to the Fleurs, there's some guy that feeds that information into the scientists. The poor old scientists are fooled. It's bizarre.
Yeah, but TT guy, when I worked as a radar technician, I've heard claims that TM. Yeah, they made the signals look like they did to make it look like it was on a curve. They shoved that in using a computer in a system that was completely analog and didn't have any computers in it at all, between the transmitter, the aerial, the receiver, the video processing, and then the video display system.
Yeah. My telescope's apparently got CGI in it. Yep.
Everybody's telescope's got CGI in it. Even my Even my camera lenses have CGI in them.
It's inbuilt CGI, is it?
Yeah,
Doesn't have
apparently.
any batteries. It runs off, I don't know, cold moonlight or something like that.
Yeah.
No, I mean, correct me if I'm wrong, Alan, but I'm talking about the early radar. I'm talking about World War II era radar. And I remember seeing, I don't know whether it's true, you could correct me if it's not, but from the movies and things like that, all you could see actually on the radar tube, or when they looked through, it was just a whole, to me, or to the average layman, was just a load of squiggly lines. But obviously it took somebody to read that to understand what they were looking at. Would that be right? Just a load of squiggly lines on a tube.
If you look at, say, the film The Battle of Britain.
Yeah, that's what I'm probably thinking of. Yeah.
They're actually showing chain home radar.
Yeah.
Okay. Chain home radar use what we call an A-scope display. So that's literally an oscilloscope display that has time along the bottom, just like you would do in school when you plugged it in school, and then the output of the receiver pushes the display up and down, and of course it then repeats each time they send a new pulse out. You get a new line drawn, and yet you basically work out that there's a target there by the fact that it's been pushed up. The signal's been pushed up high. But yes, you do need to be quite skilled to read it. And of course, it tells you nothing about the direction of the target. There's another system that reads off the direction of the target, because they essentially use the phased array. So you have a multitude of receivers, and you look at the phase outputs of the receivers to get the bearings.
All right. Okay. So basically the display we saw basically all they'd see is that, okay, there's a target out there somewhere, and then you had another instrument that would actually tell you the direction it is in.
Well, because we know that if it's 300 milliseconds off the end of the from when the pulse went out, we know it's 400. We know it's 450 kilometers away. Although that's rather too far for chain home. But
just an example, yeah.
For every 10 microseconds from when you fired the pulse that you see on the thing, the target is 1,500 meters away. So it's so that's
easy to calculate.
They draw a line out, and whatever the length of the line is, it tells you, because the time it takes to draw that line tells you what the range is.
Yeah.
And then they literally, it's just like looking at a normal oscilloscope. You see that you have the time base, and you have the signal going up and down.
And of course, they knew roughly what the directions that the aircraft are likely to be coming from, because they knew where the airfields were, right?
Yeah,
so going to be roughly in the direction.
Like I said, because there's a whole range of aerials listening to the signal.
Ah, right, okay.
You look at the output of different. You can look at the output of different areas. The receivers attached to different aerials, and you can look at the time difference between when the two signals arrive. That's what's called the phase difference.
Ah, right, yeah.
And from that you can work out the angle, but they have a different system for doing that you don't see. So you would be looking at the target, and you would be adjusting to get the angle from a different set of data than what they're getting the A-scope display from. And then of course, after that, they developed the PPI tube, which is the circular tube where you see the sweep going round. And that just works because instead of the signal making a vertical line on the screen, all you do is you just use that to brighten the output to the screen, like a TV. So when you get a target, you get a signal where you put that on the brightness control, and it automatically brightens the output. So you see it as a dot. And that makes it much easier to read.
There you go.
And now I'm sure I've bored everybody to death. So
No, it wasn't boring me, actually.
That's okay. It gave me time to go and make a coffee.
Yeah, I saw the little icon come that says your way.
Yeah, I'll
with a
throw
cup of
that
coffee.
up. Throw that up just so you know what's going on.
You're making.
Right, I'm just buying some batteries on eBay.
You what? You what on eBay? What?
Buying some batteries.
Oh.
Because I tend to get through a lot of batteries, all my paintball gear, and my stores are running low. So it's like, shit.
And your vibrator.
And you what?
Your vibrator.
I don't have a vibrator. What good's that to me? However,
how do we get to Herschel to paintball to vibrators? How did that work?
I don't know. How do you do that?
Actually, wherever he is, that's his fault.
You have TT guy in here.
Nah.
Okay, it's his fault. Just see how we look on YouTube.
Anyway, Herschel, the unsung hero of the world of astronomy. I don't know.
Herschel and did he say his daughter or his wife?
His
daughter. His daughter, yeah.
Yeah, what's about she got gypped, and it's only mentioned because now we're all, perhaps you should mention the women that helped out, or did all the work.
Yeah, probably. Yeah.
When Dad took credit.
Yeah. I think I'll probably come across Herschel like reading stuff somewhere, but it probably just like skimmed over it. Probably didn't even realize what Herschel was at the time.
I think you're thinking of Hershey's chocolate.
Well,
we don't get Hershey's over here, so no, I'm not.
Either do we.
Because he discovered infrared radiation. Is that what?
Yeah, apparently, and Uranus.
And
well, I would. Sorry, go ahead.
And Uranus.
Oh yeah,
Uranus. Stop saying that, will you? Uranus.
Hey, I'll use that one thing next time. See up in the top corner.
Yeah.
Yeah.
Yeah, TT guy, can you just back away from your bloody camera?
Yeah, well, you see right up his nose then. Wasn't it pretty sight?
That's entertainment.
Why is it the average of people wearing glasses is 4 out of 5 people, sorry.
Yeah, that's probably
because ruined your average.
What?
Farmers can't see now. They can't see a bloody thing.
I see a bloody thing, no.
Why have you all gone fuzzy? That's
I'm probably the only one that's not wearing glasses at the moment.
I may or may not be wearing glasses. You can't tell, can you?
You usually do. You usually do. When the times that we've seen you, you've got your glasses on.
There you are. That's now going out of focus. That's how bad my eyesight is.
Now you know how I feel.
But these are very focals.
I should wear glasses, but I never do.
You'll regret it later in life, I bet.
Yeah, I probably will. Later in life, I don't know how much later I can get.
Yeah.
Hey, look, I don't know about TT go. I know this is a problem that Terry's going to have even worse. But I'm not looking forward to the fact that in a couple of years' time, I've got a birthday that's going to start with a new digit.
Yes.
Ooh.
Yes.
A digit.
I've got about 5 years before that happens. So,
A digit that's going to be 5. Sorry, bigger than 5.
Yeah, you're catching up to me, Alan.
Is it the number between? Is it the number between 5 and 6 or 5 and 7? Sorry,
5
I meant
and 7,
to say.
actually.
Yeah.
Between 5 and 7, and I really have no wish to be any age that includes that.
Mine's going to have a 2
However,
at the end of it by the end of
I'd
this
rather
year.
have that than the other alternative.
That's what I felt when I hit 50. It's the same thing, but it's like whatever. Can't do anything about it.
Don't worry, Alan. When you hit 60 and then when you go to 62, it probably won't make any difference, like how I feel.
Yeah.
just got to get a younger woman to feel.
Just get a woman to feel. That'd be a start. The one that won't slap you in the face after you've done it.
You can purchase those.
True.
Hey,
I know, desperate. What's on that?
Well, seeing as we're being Sorry, Alan.
So I'll sort this out. I'll do this for the next stream. But I think I've just found a really nice set of images from Apollo 17 that shows a nice that can be turned into a panoramic stitch.
No,
because that
There's
was
quite
a
a few
lot
that can do it.
of slide film, but you can do it a hell of a lot easier with once it's been digitalized, can't you?
Digitized.
And
We know what you meant.
And it also shows that they went, oddly, in the morning.
Were all the Apollo landings in the morning?
Yeah.
The lunar morning, anyway.
The lunar morning,
Yeah. Well, because they got more daylight, didn't they? So.
Well, they
have
worried more about temperatures, I think.
Well, yeah, that as well.
That's why they didn't sort of land at lunar midday or anything like that, because there'd have been a lot more sunlight. It would have been, you could have had sort of effects and extra loading on the cooling systems and all sorts of things. So yeah, they all landed in the lunar morning because, of course, the lunar day is slightly longer than our 24-hour day.
Why didn't they land on the dark side of the moon?
There's no dark side.
Why didn't they land on the night side? Well, because you wouldn't be able to see very much.
Yeah, you wouldn't be able to see, and it'd have been bloody cold.
Yeah, I mean, don't forget as well. I mean, they would have need lighting. So that would have been more weight to add,
and a signal.
And a signal. Yeah, exactly.
As
would be difficult.
The Chinese found out when they landed their rover and whatever on the far side, you had to have something to act as a relay station because you're facing away from Earth and the moon's in the way.
You don't have to be on the far side of the moon to land at night, do you?
No.
Or at least to land at lunar night.
How long was Apollo? How many Earth days was Apollo 17 on there? Because they were on for quite a few days.
17.
A few days, wasn't it?
2 or 3 days.
3 days, yeah. At least
3 days. I can't remember off the top of my head. It was something like that.
Well, as I was going to say,
how long is a
a
lunar night or a lunar day?
It's a 28 and a bit day cycle, isn't it?
Yeah, that's how long a lunar day is 28 plus our days.
Right, that's what I was thinking. It probably was.
Half of that. Yeah, they all landed in the lunar morning, and they were there. Apollo 17 was there at least 3 days, and that's still the lunar morning because it takes.
Yeah. Right. Yeah.
Best part of a fortnight to go through.
Whereas Apollo 11 was there for just several hours.
No, because they landed and then they slept.
Well, they were supposed to sleep, and they said, "Fuck this! I'm too excited."
Well,
right?
They did.
As the story goes,
they did have some downtime.
Yeah, right. So December the 11th to December the 14th.
I don't know if they actually quote. That's the exact quote they said, TT.
Yeah.
Yeah, because I think everything was recorded, right? So they've got to be
yeah, so they
the P's and Q's.
Yeah.
Yeah, so they landed on December the 11th at 7:54 UTC, and then lifted off again on December the 14th, 22:54 UTC.
Which
so,
is
days?
17.
Yeah, right. 3.5 days they were on there.
Yeah, I think that was the longest EVA durations, I think, wasn't it, out of all of them? I think. EVA duration, 22 hours, 3 minutes, 57 seconds. First 7 hours, 11 minutes, 53 seconds. Second, 7 hours, 36 minutes. And then the third, 7 hours and 15 minutes. So a total of 22 hours, 3 minutes, 57 seconds.
Yeah.
Got some good science in that one. Needed to.
Yeah.
That will carry on.
They'd scratch the other. This numpty. Oh my god.
Oh, him.
Well, I've only got 2 videos.
I only discovered him recently. Yeah.
Well, I've only got 2 videos to play, so to finish off with.
Is this going to be
Jesus' brother?
Yeah. Very.
Is this going to be the exact opposite of what we just had with Paul?
Probably.
Yeah, pretty much.
Yeah.
I'd guess that. I did have a couple of other videos, but since we're running behind, I narrowed it down to 2.
Well, you got something in reserve for Wednesday if you stream, ain't you?
Yeah, I got a couple. There's a couple of others we could have watched.
Wednesday. Let me. What am I doing?
I reckon that
Wednesday?
CC one will leave for after Lindsay
Ooh.
on Wednesday.
I haven't actually got anything scheduled at the moment for Wednesday. Bloody hell!
Oh,
That makes a change.
We've got
No,
everything
I'm happy with
ready.
that.
Got sound for the peanuts. Unmuted.
Yeah, Terry,
Yes, Matt.
press play.
You ever watch a NASCAR race? You gotta slow down and make the elliptical turn, come back the other way. And when they get up there,
Well, what'd he say?
Down, make the elliptical turn, come back the other way. The Earth is on an elliptical orbit. You ain't taking that elliptical turn at 66,600 miles an hour. You'd be up in the wall. Physics.
How much elliptical?
Making a turn.
How much does he think it's? What is it? 90 degrees.
He's like, yeah. He thinks the Earth every now and again does a turn and comes back again.
Yeah.
The handbrake turn, yeah.
Right turn here.
Yeah, turn right.
Would you like to know what the centripetal acceleration is of the Earth towards the sun based on those numbers Paul gave us earlier?
Yeah, you can give them to me later.
0.006 meters per second squared.
Oh, there's no gravity out there. There's no gravity here either. Buoyancy, density, and weight. Buoyancy, what do you call them? Calories. What happened to gravity?
Hey, how about a little less questions and a little more shut the hell up?
Physics.
Yeah.
Physicum. Right. Earth's got a wobble. Oh, it's 1,000 miles, yeah, but so be it. It's 1,000 miles an hour. It's got a wobble.
What the hell is wrong with you people?
Yeah.
Can you smell toast?
You've never seen it when you got a wobble back and forth. You notice the stars. Never been noticing the stars. Thousands of years, nobody's ever noticed the stars got a little glitch in them.
You represent the idiocy of today.
We can't feel it. And as for that, taking turn 1 and 2 at 66,600 miles an hour, the oceans will be pushed to the outside. Now, all the weight has to be on the inside of the car. Because all the weight, once you go around the corner that fast, it's going to try to push to the outside. And them oceans will get, we'd have real low tide on whichever side's facing the sun. You know?
Oh yeah,
physics.
Yeah, sure.
Part of a league of morons.
So the Earth rotates around the sun faster than what we have the
physics
rotation.
of water.
Okay.
Seeks the lowest point, then fills up level. Why? Because water always seeks its level. Physics. You know? Simple. Simplified physics.
You don't understand it.
Overeducated morons.
This is getting out of hand.
Scientific theory, huh? No, you can't put scientific in front of a word. Make it a totally different definition.
Damn!
Physics has properties. Physics has rules. The globe debunks all them rules.
Nigga, please.
Physics. We don't feel the wobble. Nobody's ever registered stars moving back and forth during the wobble. They would have.
Yeah, they have.
Never have. Physics.
Wrong.
Okay.
You wouldn't see a circle if the Earth was doing this with a wobble. Going yonder way, and it's having to slow down, come back, come up the back stretch, come slow down.
Back stretch. We're on a racetrack.
You keep using the word. I do not think it means what you think it means.
Yes, Earth does have a wobble. It precesses, and it takes approximately 25,000 years to do one full circuit of its wobble, which is why the ancient Egyptians didn't have the same North Pole star that we do now. And you can't feel it. Well, no shit, Sherlock. I don't know. It's no wobble. No, that's probably the alcohol that balances that out. Yeah.
A question was posted on Facebook. One of the first Facebook groups was, why is it I can feel an earthquake, but I can't feel the earth rotating?
Really?
God. I mean, this is something. This is something my 11-year-old son can answer. And this is a grown ass out answering that question.
I know, that's what's most embarrassing, isn't it? It's adults asking these questions.
Yeah.
Dumb. You can expect it coming from kids, maybe, because you think, okay, yeah, you ain't quite got there yet, but adults should know better.
Yeah.
Especially our pig tickler. I mean, good grief. Physics. Yeah. One class you didn't pay attention to at school, wasn't it?
I doubt if he even actually went to the class to begin with, I think.
No,
that guy.
probably not.
At all.
He was out in the woods making moonshine with Daddy.
Yeah. Well, I mean, there's chemistry and physics involved in making moonshine, let's face it, but, not that you'd realise.
Yeah, you can learn that by rote, can't you? You don't need education for that.
True.
Simon Dan's poised, ready
Dan.
to go.
Yeah, he's ready to go.
This is a good one from Dan, actually.
I haven't watched this one yet. I saved it for now.
Okay.
Without a doubt, the most stubborn flat Earth content creator out there is Level Earth.
What'd you say? I pressed it without somebody saying it. Sorry.
No, I was going to say you TT guy could say it this time, but you already pressed it. So it's too late because he knows now.
Okay. Sorry, TT.
You want to say
Observer.
it, TT guy?
Too late now. It wouldn't mean the same thing.
Couldn't find our mute button. Hey, why don't you play it?
I've been responding to his videos since the very beginning of this channel. Who remembers this classic?
Okay, so where are we at here? What we're actually getting is, let's have a look, what's the difference? On the journey, elevation is, I go up 16,322 feet, I come down 16,312 feet. Wow, difference of 10 feet. 10 feet of difference.
You heard it here first, people. There's only 10 feet of difference between Weymouth and Aberdeen.
Well, we are once again allowing his dulcet tones to grace this channel, and this time he's going hard on fake space. Hello all and welcome along to another episode of Flat Earth Friday with me, Simon Dan. Thank you very much for joining me. Before we begin today, a huge thank you to the sponsors of today's video, Established Titles. Established Titles is a project based on a historic Scottish custom, where landowners are additional 10% off. Just click the link in the description or go to establishedtitles.com/SimonDan to get your gifts now. Right, back to today's video where we're looking at two clips from Mr. Flat Earth Fail compilation himself, Level Earth Observer. As we all know too well, flat earthers spend a lot of time trying to convince us all that space is fake. So we're going to start as Level Earth Observer is discussing a certain astronaut on board the ISS. Away we go.
Today we're going to meet 44-year-old Astrodane Victor Glover. Victor apparently has been on the International Space Station for nearly 3.5 months. And as we're about to see in a bit, Victor's kinda gonna give the game away. He's not even aware of it, but he is.
And what gem of evidence are you going to offer us up today, Level Earth Observer? I do wonder.
With a little bit of help at the end from one of Victor's pals as well. So let's first watch a little clip by Victor. I believe he was speaking to the Vice Secretary the other day, and then I'll come back to you.
Can he see me? Can he hear me?
It is great to see you, Madam Vice President.
Victor!
I'll just leave it there for now, guys. Looks like the Vice President's got a soft spot for Victor. Anyway, I gotta say, Victor, you're looking in good shape there, fella, for a 44-year-old.
Is he? He looks in good shape, period. No need to add the age thing on the end there. I know plenty of 40-somethings in great shape. I'm sure it must be LEO comparing himself to the world.
Bear with me. Okay, now we got this document from NASA discussing muscle atrophy, which is essentially the breakdown of muscles or the deterioration of muscles when they're not being used. Prime example would be an astronaut in a weightless environment on a space station like Victor. Pause it to have a look. I'm only interested in the bottom 2 paragraphs. Even though muscle mass and strength can be regained once astronauts have returned to Earth, maintaining muscle in space is a concern, especially for long-duration space missions. The only way to minimize muscle atrophy in space is through intensive exercise, particularly strength training exercises combined with an adequate diet.
Now, if you haven't already realised this, I think the direction that Level Earth Observer is taking this one is pretty obvious. Something along the lines of, if that's the case, then why does Victor still have muscles? Let's find out.
The astronauts on the International Space Station spend 2.5 hours per day exercising to combat the effects of muscle atrophy. But remember, the paragraph above, the only way to minimize muscle atrophy. So they can only minimize the deterioration of their muscles by training 2.5 hours a day, okay? They certainly can't maintain muscular physiques.
But does it say that, Level Earth Observer? What if you trained longer than 2.5 hours each day? Would that help?
Like our mate Victor, the glamorous astrodame. This is what happens with muscles when they deteriorate over time, when they're not used, like what would happen in a weightless environment. I'm not disputing these astronauts train, but think about how long Victor would have to train to remain buff, like he is, all muscular and healthy.
Probably more than 2.5 hours each day. And let's not forget, Victor was probably quite muscly before he went on the ISS. It's not unreasonable to assume that he may still look muscly, despite the small amount of atrophy.
Now here's a picture of Victor before he left the International Space Station. Left for the International Space Station, I'd say. Okay? With his fellow colleagues here, his fellow astrodames. Here he is on the space station, nearly 3.5 months later. Bearing in mind, when you're in your mid-40s, it's not easy to stay in shape and keep muscular and keep fit. It requires incredible discipline.
Discipline like this, you mean? Additionally, Victor had an interview once whilst he was on board the ISS with none other than Mr. Tom Cruise. Tom asked Victor what the hardest thing to do was whilst on board the ISS, and Victor replied with spacewalks and went on to say this: "But it's also very physically demanding. You're moved around a suit that can weigh with your body as much as 1,000 pounds, and you very rarely use your legs. It's like running 2 marathons but on your hands the whole time. Your hands and fingers are very sore when you're done with this. And so that's the most physically challenging thing." Imagine the effect that that sort of thing is going to have on your arms.
Excellent diet, lots of hard training. But it would seem, strangely enough, Victor looks healthier and stronger and seems to have been doing more training since he's been in space. Rather than deteriorate, it's almost like Victor's been to a health spa. Sorry, you might want to choose people that deteriorate given the stories you tell us, rather than people that seem to get more and more muscular, more and more healthy. It's as if Victor is playing his part in a political pantomime blended with a heliocentric space pantomime. Dear oh dear, these people can't keep their stories straight.
Now, in the same interview, Victor also said this: "Not at all. By the time we went out the door, I felt stronger actually, and over my mission I did lose a little bit of bone mass. I lost about 2% of my bone mass, and they say I'll have that recovered in about a year. Muscle mass I actually gained. So I told you I lost 2 kilograms in the first 2 months. At the end of the mission though, after the complete 6 months, I was 4 kilograms heavier, so I gained back that 2 and then put 4 more on. So I came back with more muscle mass than I launched with." You really need to research the characters you're trying to dismantle, Level Earth Observer, before you make a video.
They can. So if that wasn't bad enough, Victor and his training regime giving the game away. Rather than deteriorate, Victor looks a muscular picture of health. And he really does give the game away. So we thank you, Victor, for intensifying your training program at your villa or wherever it is you're staying, your pantomime villa. Because you look much healthier, much stronger, much more muscular. Having been in space for 3.5 months. Which is bizarre, me old mate, considering most of your muscles, most of the day, aren't even engaged.
Which is why he works out so much. Couple that with the spacewalks he was talking about and you can see why.
So we're going to laugh with you, Victor, at the downfall of the ISS through your healthy regime, me old mate. We love it. And just before we go, let's get your pal, the Japanese fella, to expose this nonsense even more. Bear with me. Now here's Victor's mate, the Japanese Astro Dame Noguchi, giving it away even more, this time with a harness. We had Victor give it away with his health regime. We got Noguchi giving it away with his clown show harness. Let's have a quick look at this old video of mine. This is from 3.5 months ago, when Victor and Noguchi supposedly joined the ISS. Let's have a look.
£50, he doesn't even mention the lady's blonde hair.
Here he comes then, here comes our mate. I should add, Noguchi said the SpaceX rocket that he travelled on, right, was the most comfortable ride ever. Him being a veteran of space, okay? So you'll get where I'm coming from, what I say here. The SpaceX salesman himself. Now look at his back here. See it? Sticking up like that. It's a clown show.
So clothes aren't allowed to crease then. And he still haven't mentioned the lady's hair. Ridiculous. If this is all you've got, Elio, then I feel sorry for you, buddy.
Well, we got to ask you, our old mate here, Noguchi. And I'll pause my previous self there. And of course, Noguchi, in his moment here of pantomime ecstasy, is kind of giving the game away. So we got Noguchi hanging on wires giving the game away. And we got Victor's superior health program also giving the game away.
Yet you still don't mention the lady's hair. Now, if that's not enough Level Earth Observer for you, then I have got excellent news as we take a look at another one of his videos where he's reviewing the new James Webb Space Telescope. Let's have a laugh. I mean, take a look at that one.
NASA reveals James Webb's first focus image of a single star and says it's so good the Space Telescope could exceed science goals. Now that sounds great, but the problem is when we actually look at the image that everyone's getting themselves worked up into a frenzy over, turns out the image is just the usual tosh, just a better quality CGI.
But what do you want, Level Earth Observer? If it took a photo of something never seen before, you'd cry CGI. If it took a photo of deep inside an Andromeda galaxy, you'd cry CGI. If it took a photo that went so far back in time that we'd literally see atoms being created, you would cry CGI. But here we are improving the images that we've already captured in our universe and it's still CGI.
Now bearing in mind, this space telescope cost $10 billion. And yet they're citing CGI images as scientific proof.
So you want proof that stars exist? Just look up at night, buddy.
Now bearing in mind, as I highlighted the other day, the only proof that this space telescope is residing in a scientifically impossible environment has come from this space satellite known as Gaia, which blatantly has taken its influence and design build from a Mexican sombrero hat and blended it with a Victorian top hat.
How something looks does not dictate its competency.
But this cartoon hat, which is the only proof that the James Webb Telescope is actually in space, and this is what is cited. Pixelated tosh. So we've got a cartoon satellite that looks like a sombrero hat blended with a Victorian top hat, citing pixelated nonsense.
That's actually quite impressive. It's a photo at a distance of over 600,000 miles, capturing something only 13 meters in length.
As somehow proof that a space telescope that costs $10 billion is residing in a scientifically impossible environment. And what makes it even worse is when we look at the space telescope's first image, and like I said, it's nothing but the usual tosh CGI. So we've got a cartoon verifying a space telescope which produces CGI. The verification that came from the cartoon came in pixelated form. If you're defending this stuff still at this point in time, you really need to have a word with yourself, because by defending this tosh, you're actually pushing tyranny and human suffering, because all of this stuff costs millions and millions and billions of pounds.
Gibberish. Absolute fucking
used
idiot.
to better mankind and look after people here on Earth.
Then why aren't you having a go at the US defence budget then? NASA's budget is $22 billion. The US defence budget is over $800 billion. And whilst we're at it, why are you spending money on things you don't need, Level Earth Observer?
That's being spent on who knows what. Goodness knows what that's being spent on. Because it's clearly not being spent on space exploration, because heliocentric space is scientifically impossible anyway.
Says the crane driver. Now, that's nothing against crane drivers in general, but science isn't really their field, is it? Well, there we go, another Flat Earth Friday, all done and dusted. Thanks so much for watching, poor old Level Earth Observer. He's hanging on like a desperate limpet, isn't he? Once again, a huge thanks for watching today. It genuinely is appreciated. If you enjoyed it today, please do consider subscribing to the channel. We're on that push for 500,000 subscribers. I'd love to get there by the end of the year. If you really enjoyed it, of course, hit that like button as well. Just enough time to once again thank Established Titles for sponsoring today. Remember, click the link in the description or go to establishedtitles.com/SimonDan to get an extra 10% off any order you make. I've been Simon Dan. Have yourselves a fantastic weekend, and I'll see you on Tuesday for some brand new tinfoil. I know. See you then.
Brand new.
What an absolute cretinous moron.
Yeah, does he really think this shit is convincing? I mean, looking at the guy's physique, I mean, do you look very different to you? Not to me. I mean, what the fuck?
It's the bit where he says that if you're defending this, right? First of all, whatever NASA produces is not proof of anything. They're not trying to prove anything to anybody. You can choose not to believe it. That's your fucking problem, right? But don't come and tell us that because we believe it, therefore we're going against everything that's in humanity and all the rest of it, all that crap. That's just horseshit. I mean, let's look at what space exploration has actually brought, particularly with research on the ISS. They've actually developed medical procedures because of research done on the ISS. Artificial limbs, research in all kinds of different medical science. They've actually saved lives, but this moron comes up with that crap. Honestly, gets my goat sometimes.
You wouldn't tell.
Have a little rant. You got to have a little rant every now and again.
He's one of the ones I'm pretty much getting sick of hearing, because it's has that effect.
Same.
Yeah, because it is this scientifically impossible to be in space. Yeah, whatever, mate. Yeah, and they trust you with a tower crane. They don't trust you with a shovel.
Yeah, exactly. Like Dan says, he's a crane operator. He's not a scientist.
But his followers back it up. His followers love him. You go and read the comments on his videos.
I have many times. And here's the thing as well. I mean, this is what's even worse. I mean, some of you might have already seen it. He did a video about basically one of the Dragon capsules attached to the ISS currently, where there was two attached. And one of the shots from NASA was showing basically a large part of the ISS showing the other Dragon capsule that wasn't undocking, that was perpendicular to the horizon of the Earth, whereas the one that was actually undocking was horizontal with it. And of course, he pointed that out, and he then actually realized that in the actual image, you can actually see the nose cone of the other one. But
it was pointed out to him.
And it was pointed out to him.
He actually let the comment stand on his on that video.
Yeah,
which is rare because usually he blocks everybody.
But just emphasising what you were saying, though, Farmers Boys, is that all the people on there, including David Weiss, by the way, when he produced that video, say, "Oh, well done, very observant of you."
Exactly. They're all, well spotted, yeah, NASA, physically impossible space, yeah. And then somebody said, actually, there are 2 capsules, and you can actually see the nose cone of the one that's departing.
Yeah, that's the thing that gets me. It's like they're all lacking it up. They just
his pinned comment is him sharing an unlisted video where he's basically going, "Oh yeah, well, you think you've got an argument, but why haven't NASA? Why didn't that camera be in a different place to show the other capsule? Why didn't it show it undocking?
Yeah.
There is another camera that shows it undocking because you showed that clip. I think if he'd only got like half a dozen comments and somebody said, "Oh, by the way, you idiot, you can see there's another capsule there," I think he might have deleted that video. But because he'd got all of these comments and all of this backslapping, and "Oh yeah, great stuff, well done, you've really showed it to them," and then somebody went, "You idiot," he's left it there. But it's just making him look even more ridiculous than he already is. Oh look,
and his so-called apology video is kind of like admitting to it. Did you see that as well?
Yeah, that's the one. That's the unlisted video that he's linked to. His pinned comment is him saying, "Look at this," and then immediately somebody said underneath, "Well, why did you leave this video up then?" That's what I think. That's why he's left it up, because he's had such good interaction with all of his dumb followers. And
that's the fact. I mean, he didn't really come up and sort of admit, "Yeah, I got it completely wrong. I'm sorry, no problem. I'll leave it up for a little while, but then I'll delete it." No, what he actually said was, he ended up saying was, "Oh, I think the Globers have got a get out clause here and all the rest of it. Why couldn't have NASA have done this, done that, and all the rest of it?" There was no kind of admission at all.
No.
Not straight up
Do you
admission.
think we should wake Alan up before he falls on the floor?
Alan!
There he is.
He's awake.
Yeah, we just saved you from falling on the floor.
You were leaning. You were going.
You're definitely heading towards your right hand side of your.
Yeah.
It's that vodka. That's what it is.
Yeah, that's not water he's drinking.
It's not water. It's not water.
Definitely drinking after last night.
Yeah. Oh, you was out in the sauce, weren't you, mate?
Oh, was he?
Yeah. Oh. I think I was fairly. I think I was actually fairly good. I think it was only 2 pints of Spitfire and a G&T.
That's not too bad.
Spitfire, I've not had that for a while. I made a mistake having 2 large glasses of wine last night on Pipstream, and it was like I can't keep my bloody eyes open. I was so knackered.
I know does alcohol do that to you when you get older? It just makes you want to go to sleep.
Yeah, it does for me.
I'd had one of those weeks, and I think it was Wednesday. I was awake at 3 o'clock in the morning, thinking, "What am I awake for?" Didn't manage. I've been knackered all week, and then you have a glass, and you think, "Oh, that's going down well." You have another glass, and then it's like,
yeah.
Oh yeah, and then I had a very, very large glass of single malt scotch when I got home.
Yeah, that might have. Yeah,
that might have helped
that
you.
might have tipped the balance. Yeah.
I don't even drink after dinner time, even or when I've had food. I just can't.
Yeah, I had a few drinks. Oh, sorry, go on.
I also got the munchies about midnight, didn't I?
Well, that didn't help. Yeah, I did that a few weeks ago on the Shields. I made the mistake of having a few drinks, and I must admit, I was a little bit pissed by the time the Shields started, and then about half an hour into it, I was nodding off like, God, I can't stay awake for this. I managed it, but Jesus, I want to go to sleep.
I was just going to say, if you were on the spirits, you didn't know eggs were involved, were there?
No, there was no eggs involved this time. All salt, all water.
I had 2 glasses of wine, and I thought it's no good. I've got to go and make a cup of tea, because otherwise I will just be asleep. But yes, Global Mum, you're right. Pip had 1 or 2.
Yeah.
I think Pip usually does have 1 or 2 during the streams, doesn't she?
Yes.
Oh, we're just in time for Lindsay Judy's here.
At the time,
I thought you'd already had Lindsay.
I've got to go and make a cup of tea. We'll forget about this.
Oh, we've been going for nearly 2 minutes to go, and we've been going for that magic number. So I think we'll wind her up here.
Oh, Oh yeah,
I'll say me goodbyes out there. Yeah, time flies when you're having that F word.
Yeah, it's always better to end it just before an hour or an hour, or each hour point.
Yeah, but we're trying to do a
And have a
sound
hot
bite
sweat.
at the end now, but we keep getting it cut off at the wrong time.
No, we don't. We keep getting it cut off at the right time. Just as I'm halfway through it.
Well, it's working out well.
Yeah.
Well, you better say your goodnights before the hour ticks over then.
Yeah, I'm trying to type out me thing.
I think I could just about risk getting the grass cut.
Yeah, it's a nice day here.
Well, problem is
Very
it
nice
rained last night, so and it was getting a little long because I should have cut it last weekend, but the green recycling bin was absolutely bloody full, so I had to wait for that to get emptied. And then of course it's rained, and of course it's got nothing to do with my landlady coming down from the lakes, and she'll be popping around. Well, it must be tomorrow now. She ain't coming around now.
You want to come and do my lawns, front and back?
I don't want to do mine, but
Yeah, I'll do it if you pay me.
Yeah,
I think
I'll
the
pay
grass
it.
is dry enough, and there are some horrible looking clouds floating around. But if I get it done before it rains again,
You may have
I'll tell you
to.
what, Terry, you'll have to. Yeah, go on.
You may have to whippersnip the top of it down a bit so you'll actually get the lawnmower through it.
Oh, that's right. As long as you pay for my flights as well as paying to actually do your
Oh,
lawn. That's
okay. Do I have to pay for that as well? Okay.
Oh yeah.
Yeah. He wants a free
Sounds
holiday,
fair.
yours. That's what he's
Yeah, it sounds like it.
Yeah.
It sounds like it.
I'll do your lawn, and you can feed me and pay for my flights.
I suppose you want a
And water me.
beer too when you're finished.
Yeah, of course.
Yeah, Carlton
Goes
Draft.
without
That's all
saying.
I drink.
That's all right. I'll do.
It's full strength, full bottle
Frosters,
beer, not that
Frosters.
short little stubby bottles that they have.
Sounds good.
Okay. Who do we have out there? Dora. TT's out there. Judy, Glover, Stevie, Wally, Farmers, John Giovanni, Jinx Yu, Zebulon, Stevie B, Dora. I've got to scroll up further. Dave Cannabis. I know Carl was there earlier. Clive. Irish Stew, Facty. Who else was there? Oh, Jin. Jane Laugh. Jane. How do you pronounce their name? Jane C. Laugh or JMC Laugh? Yeah, I can't work that if that's how it's meant to be said. I already said Clive. Sam Cam. Biggest Doggers. Spooky.
oh yes, Chelsea laugh.
Did I say Zebulon? 181. Mr. Ball. Stevie B. Joe Whip. Brainery.
See, Wes Wally is out there as well.
Yeah,
Yeah.
Wally was out there.
Yeah, Wally's been here.
Yeah, Wally drops in now and again. He left a message down there. I forgot to read that one. So that Chinese guy, I don't know what nationality he was in the last video. Wally said he'd been on the space shuttle and one other one. So he's been on three missions.
Yeah, he flew space
Probably
shuttle.
would have been Japanese, not Chinese.
And
Jaron Urism, John Stock. That's it. I can't go any further unless I've missed out on you.
They don't let the Chinese on the International Space Station.
There we go. Okay, that's everyone. Oh, did I say Dora?
Yeah, I
Dora
think so.
and Stevie B's put up there.
Smart cookies, Dora. Very smart.
Oh, and can I just say happy 46th birthday to Newt?
Who?
Happy 46 to Newt.
Who's Newt?
Who's in the film Aliens?
Oh.
The little girl Newt.
Wow.
Oh.
Okay.
She's 46 now, is she?
I just saw something on my Twitter stream and it says, oh, it's her birthday today. And I thought, hang on, Carrie Hen, hang on, let's have a look at the IMDb page. Yes, she'll be 46 today.
Wow.
How old is she when they made that movie then? She must have been a what?
Yeah,
She
6 or 7 or
was-
something?
No, she was 10.
Blimey, has it been that long since that movie was made then?
1976. Yeah, Aliens came out in 86. She was 10 when she started
long
that
ago.
film.
Wow.
She's only done 2 films. That was her first one, and then she did Thunder Island 2 years ago. Never heard of that. But yeah, I just saw it on my Twitter stream. I thought, well, how old is she then? Because you saw it's her birthday. Yeah, she's.
OBS didn't crash on us, which is good. So
there you go. Aliens is 36 years old.
There's supposed to be something else new coming out that I heard on the grapevine somewhere. Star Trek or Star?
There's a new Star Trek series.
Yeah, coming out soon. Yeah, they were discussing that on the Shields the other night.
Well, actually, it's if you know where to look, it's come out already.
Is it? Okay, I'm going to have a look for that.
Star Trek: Strange New Worlds.
Yeah, I'm going to have a look for that later and see if I've actually got it.
I've got episode 1 available at the moment.
Okay, I'll go and have a look myself and see if I can find it on my quote.
Because
quotes,
that
video
covers Enterprise pre-Kirk. So
yeah,
it's
that's right.
Christopher
That's the right quote, Dora. They mostly come at night. Mostly.
They mostly come out.
Mostly.
Affirmative.
Okay. Good night, panel. Good night, Alan. Good night, Farmer. Good night, CT guys. Thanks for dropping by. Thanks, Matt. Sorry, Matt.
Good
Bye.
night, folks.
Can I go now?
Yeah.
You said that as well.
Yeah, you can go now.
Off drop.
You can.
Yeah, but
You're going to say goodnight to the peanuts.
Newt said that as well.